Hello, good morning, everybody.
Hello, good morning. This is Arijit Roy from Indian Institute of Remote Sensing, Dehradun.
Yeah, welcome, sir.
Thank you, and thank you for inviting us and letting me be a part of this important webinar series.
Good, good. This was the first talk today. Yeah.
Yes, sir.
I'm V.K. Jain. I'm retired scientist from SAC Ahmedabad, ISRO. I have been involved, associated with the development of satellite communication payload for inside.
Yes, sir. I have. We have heard about you a lot, and I think I have met you when I was there in IITP and SAC.
Yeah, yeah. Hello, Chintamani. Now, good morning.
Hello, sir. Good morning. Hello, Roy, sir. Good morning.
Good morning. So shall we start? Because I have another meeting at 11 o'clock.
Okay. So good morning. Very good morning, everyone. This is day 2 of our awareness webinar series for challenges and opportunities for science students in space sciences. I'm sure all of you enjoyed all the sessions yesterday, and similarly, we have very interesting sessions today as well. We have Dr. Ajit Roy, who is the head of Disaster Management Studies Department of IRS ISRO, and he'll be talking us about the challenges and opportunities in the from the disaster management perspective. Very good morning, sir. May I request Dr. Veena from PC Jabin Science College to introduce our today's speaker.
Thank you so much, sir. Very good morning to all. It is my privilege to introduce guest person, Mr. Dr. Ajit Roy, who is a scientist in Indian Institute of Remote Sensing, Indian Space Research Organization, Dehradun. Sir is presently head of the Disaster Management Studies Department at IARS. Sir had completed his PhD in botany with specialization in restoration ecology from Banaras Hindu University, Varanasi, India. Sir has been working in the field of geospatial technology at different centers of Indian Space Research Organization from 2004. His research interest is in remote sensing of environment, geospatial modeling of impact of climate, and anthropogenic forcing on the terrestrial ecosystems, mainly influences on natural disasters and forest fire ecology and risk assessment. He has used temporal hyperspectral satellite data to assess the spatial variations in the ecosystem level processes and flows, especially of nitrogen. He has guided more than 25 MTech or MSc dissertations and has supervised 5 PhDs. Dr. Roy has more than 100 publications, which include peer-reviewed journal publication, 22 peer-reviewed international conference papers, and has authored 1 book, numerous book chapters, and technical reports. Sir also holds the additional position of Program Coordinator, Center of Space Science and Technology Education in Asia and the Pacific, which conducts capacity building and education in various aspects of space science and application in association with different centers of Indian Space Research Organization. With this brief introduction, I request Sir Dr. Ajit Roy to continue the session. Over to Dr. Roy, sir.
Thank you, ma'am, for the introduction. So can I share my screen?
Yes, sir. You are already a co-host, so you'll be able to.
So is my screen visible?
Yes, sir.
Screen sharing ante
Yes, sir.
Is my screen visible?
Yes, sir.
Yes, sir.
Thank you. Okay, so good morning to all the participants, distinguished delegates. So today we will be talking about geospatial applications for natural hazard and disaster risk management, and what are the challenges and opportunities we face when we use the space technology for disaster management support. So before we start, I'll just give a brief background of what we understand by natural disaster. So when we talk about natural disaster, it is basically the population or the society which is affected by this disaster is what we talk about. And it is not just the people, it is also the things which are on which the society or the people depend upon, like dwelling, energy security, food security, say water security, health security, ecosystem services, the economy, communication, infrastructure, all of these aspects which influence the society, which influences the society and its ability to survive, is what we talk about when we refer to the natural disasters. So before we start, I'll just briefly explain to you some of the terms which we use when we talk about natural disasters. See, we all talk about the terms hazard, exposure, vulnerability, risk. So here we will try to understand what we mean by this. So when we talk about hazard, it is basically the disruption or the loss which happens due to the unexpected event. Here, in this case, it is natural disasters like flood, cyclone, earthquake, etc. When we talk about exposure, it is basically the component of the society which is affected, like the people, the property, etc. And then we have the vulnerability. The vulnerability like economy, environment, the adaptive capacity of the society, which is basically the ability or the inability of the society to resist the hazard. And risk is basically the exposure, the disruption or the exposure to the unexpected event, and the vulnerability of the society to overcome the hazard is what we know as the level of risk which an area or a community has. So with this background, let us see how risky is our world. If you see this map of this world, all the areas which are in red, which are basically the areas which are expected to be under natural hazard and economic loss in the coming future. You see, most of the areas are heavily or densely populated. Let us take from Japan, China, South Asia, the Gangetic plains of India. Then you have the areas of Middle East, the entire Europe, the eastern part of USA, the Panama, Mexico region, the Caribbeans. All of these areas which are densely populated are actually risky. And if we see the annual average losses because of disaster, which is from say for the next 15 years, it is basically the flood which affects most of the people around the world, followed by earthquake, and to some extent the storm surge as a result of tropical cyclones. So how do we, or what is the mechanism which the global community has identified to manage this risk? So initially in 2005, as a part of a Hugo framework of action, we had the disaster risk management framework, which basically was a combination of government and organizational coordination and cooperation, along with the sharing of knowledge and information. And in this domain, they identified 3 verticals, that is risk identification, risk reduction, and risk transfer. So when we talk about risk identification, it is basically the historical, analyzing the historical hazard data and identifying how the trends of the hazards are changing. And it also emphasized on identifying the exposed assets and vulnerability and quantifying the risk. When we talk about risk reduction, it is basically the preparedness of the society to the impending risk, such as early warning system, emergency planning and response capability. And when the event occurs or a hazard occurs, what are the mitigation plans from medium to long-term sectoral planning? And the third vertical was the risk transfers, like insurance, bonds, and other alternative risk transfers mechanism. So this was the framework which was in action from 2005 to 15. In 2015, we had the Sendai Framework. So Sendai Framework basically aims to achieve a substantial reduction of disaster risk and losses to the various components of society like lives, livelihoods, health, economy, society, physical, social, cultural, and environmental assets, as well as the businesses, with a goal to prevent new and reduce existing disaster risk through the implementation of various inclusive and integrated policies, such as economic, structural, legal, social, health, cultural, educational, environmental. The list continues, so that the people are, or the societies are able to reduce the hazard exposure and vulnerability and increase the preparedness for response and recovery. And for these, to achieve these goals, the Committee of Nations in this meeting, which happened in 2015, identified 7 targets. That is to reduce the disaster mortality by 2030, reduce the number of affected people, reduce the economic loss, and reduce the infrastructure damage by 2030, and improve or increase the disaster risk reduction at national and local level through various strategies, improvement in international cooperation for disasters, improvement in early warning system and disaster risk information by 2030. So to achieve these targets, 4 priorities of action were identified. That is to understand the disaster risk, which, if we translate it as a scientist, is basically understanding the physical basis of disaster, investing in disaster risk reduction for resilience, that is improving the infrastructure, both space and ground-based section, then increasing or improving and strengthening the disaster risk governance to manage disaster risks. So when we talk about governance, it's basically timely dissemination of information. So we have to improve the methods and ways for effective dissemination of appropriate information. And the 4th priority of action was to enhance disaster preparedness for effective response in recovery, rehabilitation, and reconstruction, which basically translates into development of early warning systems and strengthening the logistics for various mitigation methods, applications. And all of these are basically integrated into the Sustainable Development Goals of the UN, wherein the no poverty, zero hunger, good health and well-being, quality education, clean water and sanitation, affordable clean energy, sustainable cities and communities, climate action, life below water, life on land, all of these 17 Sustainable Development Goals have the components of Sendai Framework integrated into them. So when we talk about geospatial technology, it is basically a convergence of a number of high-end technologies like ALTM, the IT bandwidth, the GPS, remote sensing, GIS, ICT, various photogrammetric suites, total stations, and all of these integrating, all of these provides the total turnkey solution for various applications of geospatial technologies for disaster risk management. So before I move further, I'll just give a brief glimpse of what the disaster management support program of ISRO is. So we have an institutional mechanism wherein we have a disaster management decision support center at NRSC. And this is in association with various nodal agencies of Government of India like Ministry of Home Affairs, PMO, MOA, Cabinet Secretariat, NDMA, NIDM, state agencies, NGOs, etc. And this provides information in various natural disasters for monitoring and damage assessment. They also have a national database for emergency management, which we know as NDEM. We provide a VSAT-based VPN network in case of emergency or disaster for emergency communication. We also are working on strengthening the various early warning systems, especially for tsunami, flood, cyclone, drought, landslides, forest fires, etc. And we also have a hydrometeorological network, which provides real-time inputs for the various decision support systems. And there are some key developmental efforts in which we are working on, like various SAR technologies, communication equipments, various support to IoTs, TWs. And we are also thinking about constellation of EO satellites, because one satellite cannot provide a high frequency information for observation, especially for disasters. The various key areas for R&Ds are like landslides, earthquakes, precursor studies, extreme weather events, fire incidences, climate-induced disasters, etc. And we are also are a part of the international committee, and we have our international commitments through International Charter on Space and Major Disasters, UN SPIDER, and Sentinel Asia. So, if you see that for the last 3 or 4 decades, the frequency of disasters have increased a lot. So, is climate change responsible in some way for these natural disasters? Well, to a great extent, yes, because of the anthropogenic induced climate change, there are the weather has become more unpredictable and unstable, and we have more and more extreme weather events, which actually plays a very important role in many of the disasters like flood. Then you have the drought, you have forest fires, you have because of the increase in the sea surface temperature, you have various cyclones, etc., which we will be talking about in the subsequent slides. So when we talk about the role of space technology in disaster risk and disaster management, we have various components. One is observation. It's basically to collect information, and this information is used for effective decision making. So if we see the disaster management cycle, so moment there is a disaster event, you need the immediate observation to identify the extent, location, and other things about the disasters. And once you have identified it on a satellite imagery, you need to you instruct the ground people or the NGOs or the people who are actually involved in rescue and rehabilitation the exact location, so that the people can reach that place in optimal time. And this is provided by the satellite-based location services. Apart from this, when there is a disaster, the first thing which is knocked off is the terrestrial communication. So space-based inputs also provide satellite-based communication for various disaster events, so that the information from the ground can reach the decision makers for providing effective response for relief and rehabilitation. So in all the aspects, so once the disaster has happened, we have provided relief and rehabilitation. We also identify the proper places where the reconstruction can be done. And based on the lesson learned, we have to provide inputs for mitigation and preparedness in form of early warning systems. So when we talk about the potential for space technology, what does it help? What does it provide? It provides observations on weather, meteorology. It provides satellite-based communication, positioning and emergency response, and various Earth observation applications like crop production and yield, water resources, bioresources, mineral oil and gas exploration, disaster management support, and also helps us in other aspects of environment and climate research like atmospheric chemistry and pollution. And although a few countries have the ability to make the satellites, but the satellites do not see a boundary. So many countries can reap the benefit and apply it for the benefit of the humankind. So when we talk about satellite orbits, they are of two types. One is the polar orbit, which goes from the pole to pole, and it observes the Earth in a small strip with a moderate to high resolution. And we have another type of Earth observation satellites, which are at geostationary orbit. It's a height of around 36,000 kilometers above Earth over the equator, and it continuously stays at one point over a particular area. And we can have a very, very high temporal observation over a particular area. All the meteorological satellites which we have, like INSAT series of satellite or the GEO series of satellite of US, this is basically an animation of the GEO satellite from NASA. All of these are geostationary satellites. So the Earth observation satellite infrastructure for India has an entire gamut of Earth observation satellites, starting from land and water observations like ResourceSat, 2A, 2B, and the series, then RESAT, 2B. Then we have the high resolution satellite like Cartosat series of data satellites, and then RESAT-2. We have satellites for monitoring the ocean like OceanSat-2, Saral, Altica, SCATSat, and we have the geostationary satellites for weather and climate like INSAT 3D3DR, Kalpana, INSAT 3A, which is now not in the final stages of decommissioning. So we have the imaging capability of 1 kilometer every half an hour or 15 minutes, since we have two satellite INSAT series of satellites, that is 3D, 3DR. So we can monitor the entire landmass of India at 1 kilometer resolution every 15 minutes to around 0.6 meter through the Cartosat-2 series of satellites. And we have in the between the various resolutions like awaves, then we have the LIS-3, LIS-4, and the satellites, number of satellites are huge. So what do we observe from these satellites? So when we talk about high temporal resolution satellites, like the INSAT series of satellites, they provide global level information. Whereas the coarser spatial resolution satellites like say MODIS or even our awaves, they provide the regional level information. Then we have the medium spatial resolution satellite like LIS-3, which provide us the local level information at subcatchment characteristics. And we have a very high spatial resolution like the Cartosat series of satellite, which provide us the location specific information. That is, what exactly has been damaged or how many houses have been damaged because of disaster. Apart from this, we also have the capability to have a digital elevation model, which basically provides us the terrain parameters. And this is a very, very important aspect, especially for disaster management, because this 3D or the digital elevation model, which we commonly know as DEM, is a 3D imaging capability of remote sensing, which basically what we do. Can you please mute your mic if you are not speaking? Yeah. So this is basically observing the Earth at 2 angles, and then digitally we combine these 2 images to give a 3D view of the entire Earth. And this is how basically the Earth looks like if we see a 3D view. So when we talk about natural disasters in India, it's vulnerable to a wide range of natural hazards like flooding, cyclone, drought, extreme heat waves, landslides, wildfire, and earthquake. And the studies have shown that because of the climate change, the intensity, duration, and frequency of the weather-related hazards are likely to increase. So, how does the geospatial technology help in monitoring for disasters? Geospatial technology helps us to observe the temporal patterns and changes on the surface of the Earth. And this observation is converted into a scientific representation by the way of various maps, like the hydrological maps, geomorphological maps, lithological maps, structural maps, or even the land use land cover maps. And once we have all these information as say a data cube, something like that, or one over other as layers, we are able to understand the various processes. And these processes help us to develop the, understanding these processes help us to develop the various models, which can help in forecasting the various events, especially the weather-related events, which are likely to take place. So we will go by one the various types of disasters. So we start with the geological disasters. So one of the most spectacular geological disasters are the earthquakes. It's basically because of the global plate motions, there are various stresses which are built up in the Earth's crust. And once the stress is released, you have the earthquake. And there are various methods for observing and monitoring the various impacts of this particular event. Like, for example, because of earthquake, there are various changes on the surface of the Earth, like subsidence. And the interferometric SAR can be used for detection of subsidence, even at centimeter level. Apart from that, the various geomorphic elements, like the thrusts, the folds, they also have their signature on the surface. And this can be picked up by the moderate resolution satellite data like LIS-3 or even LIS-4. Apart from that, because of earthquakes, there are sometimes the hot steam comes out from the surface, from the cracks in the surface of the Earth. And these are also picked up by the various thermal anomalies. But this is basically the observation. What about the forewarning and risk analysis? So if we see, there are, I think all of you understand what a GPS is. And then we have the DGPS, which are very, very accurate. And some of these DGPS are basically installed permanently at some of the locations, also, and serve as the continuously operating reference stations, also known as cores. And these cores are spread all across the world. And based on these observations from these long-term observations of these cores, we are able to identify how the different plates, global plates, are moving and how the tectonic activities are taking place. So this has basically helped us to understand that the Indian plate is actually not moving north. It is moving towards the northeast with a sort of rotation in the anti-clockwise direction. And this helps us gives us a good information of the strain which is building up at various locations on the tectonic plates, boundaries between the tectonic plates. Another area where people are working is basically the tech anomaly and the earthquake events. Although this is at a not a very advanced stage, but it has been observed that the total electron content in the ionosphere shows anomalous behavior. This basically there is a dip before an earthquake event, but the range of the dip is between few hours before the earthquake to 14 days before the earthquake. People are basically working on this, but this has a good potential to basically provide forewarning of an impending earthquake event. Another geological disaster is the landslides. Here also, Earth observation play a very, very important role in observation and monitoring. For example, the scars which are due to the landslides can be identified very easily using the multispectral satellite data. And using the various DEM characteristics, the slope stability from ground, as well as information on the creeping surfaces, we can prepare a very, very effective hazard map of the landslide. And such map has been prepared for the Uttarakhand region, Char Dham area route, which are actually prone to landslide and which experience immense population and tourist footfall during April, or I would say mid of April to around October of every year. Recently, last year, we had a flash flood in Chamoli. I think many of you have heard about it. There was a flash flood in Uttarakhand, Chamoli district of Uttarakhand, where some more than around 2,250 people died. So there was no rains, but still there was a flash flood. So what exactly happened? So there is basically one small river, Rishikanga, which originates in one of the glaciers. And this is the Rishikanga Glacier. And what happened is that on that fateful day, that's February 7th February 2021, this particular hanging glacier broke off from here and fell around 2 kilometers down on the base of this valley. And this entire thing, this scar which you see, the mass which fell down, was around the size of 3 football fields having a thickness of 50 to 100 meters. So you see this much big mass fell down, and the entire permafrost here got melted with the impact, and the slurry which formed here just rushed down the slope. It's a very, very steep slope, I would say. And the entire, the height of this slurry was around 30 to 40 meters or even more. And you can see this is the pre-image of the disaster. This is the post-image of the disaster. So all these trees which were earlier here had been washed off. And the Tapovan hydropower site, which is around 15 to 20 kilometers downstream from here, got totally washed up. And on that fateful day, many people were working in one of the tunnels, and this tunnel, the water entered the tunnel and all of the people died. So at that time, people did not know what has exactly happened. But because of the availability of satellite data, we could, by the evening, identify the actual cause of this disaster. So you see this entire ice block which was there had actually gone down the slope. Then we also have the hydrometeorological disasters like flood. Here also, Earth observation satellites play a major role in observation and monitoring. especially for using the microwave data. We are able to identify the flooded areas, and using a combination of digital elevation model along with the inputs for the rainfall from model as well as from the rain gauge and radar, we are able to identify the potential hazard or potential pre-computed flood maps. And in event of any disasters, the pre-computed flood map can be taken out and the people can be evacuated based on the information. Another areas of hydrometeorological disaster is extreme weather events and flash floods like cloudbursts. So we have a very high frequency of extreme rainfall events, and they are observed all over the region, especially in the Western Himalayan region. So a very, very famous event which happened was the Kedarnath flash flood, where we lost more than say 10,000 people. So what exactly happened? There is one, I'll just briefly explain to you in the next slide. So this is the Chorabari Glacier, which is just above Kedarnath, and we have a Chorabari Lake here. So on the 15th to 17th of June in 2013, there was a heavy rainfall over this particular region, which resulted in lot of glaciers, debris, and the ice to wash into this Chorabari Lake, and this lake breached. And due to this breach, the Kedarnath town, which was just below, was totally devastated. So you can see this is a helicopter image of the area just after the event when the helicopters could fly. So you see this is the companion Chorabari Glacier, then the Chorabari Lake, and this thing breached here and this entire area got flooded. But we could basically, before the helicopter could go, we could also develop a digital fly-through using high-resolution satellite and a high-resolution digital elevation model to actually understand what has happened. And this digital fly-through had actually helped the various agencies which were responsible for relief and rehabilitation to design the optimal route using which they can fly in the valley. There's another hydrometeorological disaster, though it is not as spectacular as other disasters, but it is still a very, very important, that is drought. So here also, using various Earth observation data, we can identify the patterns of the drought, we can identify the rainfall patterns, and also the various other inputs like soil resources and other things to identify the various types of drought, like meteorological drought, which is basically a departure from the long-term average, agricultural drought, which is an inadequate soil and moisture as well as rainfall, and hydrological drought, which is basically the imbalance between the surface water and the groundwater, which results in water shortage. So using all these informations as well as other ancillary informations, we are able to provide an early warning and risk analysis for drought. And this information, this technology has been transferred to Ministry of Agriculture, and presently NMCFC basically provides this information to the people. Then we have the tsunami, which is basically an underwater earthquake, because of which there's a ripple in the surface. And this, when it goes towards the coast, provides huge waves, which is responsible for all the devastation. And satellite data provides us the ability to map the impact of the tsunami in terms of damage. And we also have a very effective tsunami early warning system, wherein the network of pressure sensors in the Bay of Bengal, which are basically connected to the GPS buoys. And these GPS buoys are in constant communication through the various communication satellites to the modeling and simulation center of India, that's in KOIS in Hyderabad, And moment there is earthquake, this information is sent to the INCOIS, and INCOIS provides the most optimal risk for the tsunami to the coastal communities. Then we have the other coastal disasters like sea level rise and storm surges, which are which can be very effectively picked up using remote sensing data. And then we have the cyclone. In fact, Earth observation has played a very important role in reducing the number of deaths because of cyclone. Because we are now able to provide effective identification of the actual landing or the landing of the cyclone and where it will come. And this is shown by the cyclone filing. All of you will recall that in 1999 we have the Odisha super cyclone, wherein more than 10,000 people died. But in 2013 we had a cyclone Falling, which was even bigger and more than that particular cyclone. But in this case, since the people or the government of Odisha was prepared, so the number of casualties were in single digits. So this is basically the input the space technology provides for various natural disaster management support. Then we also have used geoinformatics for understanding the various diseases and their spread, especially for during COVID. We have identified or simulated the distribution of COVID across the country. And then we have the environmental disasters. So if we talk about environmental disasters, we have the heat waves. So using various sensors, we have been able to compute the spatial distribution of various indicators of heat waves and identified the risk and vulnerable areas to the heat wave events. Then we have the forest fires. So Earth observation plays a very important role in forest fire management, especially for active fire detection using various thermal sensors like MODIS, SNPP, VIIRS, damage assessment through burnt area estimation using the shortwave infrared bands of the multispectral satellites which we have, like LIS-3, AWIVS, Sentinel. Then we have the TM series of data. But it is not just that. We have got now a very robust forewarning and risk analysis method to identify the forest fire risk because of the various meteorological conditions as well as ground conditions. And this provides us a very effective identification on a daily basis of the fire risk in the next 24 hours. We have also been working on the various aspects of forest fire spread. So once a fire has occurred, how it is going to spread across the landscape. So this is a simulation of the forest fire spread in a part of Corbett Tiger Reserve. And you can see how the fire, it is simulating how the fire is spreading. And this basically uses the various geospatial tools like cellular automata and the WRF-based inputs to identify the effects of wind and other networks in forest fire spread. But it's not just that. This is another fly-through developed for the government of Uttarakhand, so that the higher authorities and the management can identify the extent of damage and the number of fires across the state. So you can see this is how space technology play a very important role in providing various inputs for the natural disasters. Apart from that, space technology can also observe the air quality, especially for the black carbon emission, the various aerosols because of the crop residue burning, as well as trans-boundary movement of particulates. And we have been able to provide a 6-hourly forecast on the dust, especially for particulate matter PM10, in the state of Delhi and its surrounding. There are other hazards, industrial hazards, like we use drone-based observation for identification of gas leaks in pipeline, identify fire in hazardous waste dumps. Then the the oil spills because of the collision in the sea, and other hazardous areas like slag dumps and other places. Then, because of this natural disasters, because of this climate change, the natural disasters are going to increase, especially the sea level rise. And there are many countries which, in case there is what is being projected by the various IPCC scenarios, these countries can basically disappear from the face of the earth, because most of these countries have a mean height of around 1 meter from the sea surface. And in case there is a rise of 4 to 5 meters, then all of these countries will go under the sea. But it's not just that. There are some other aspects also, like some of the large-scale singular events. You see, most of this weather patterns and weather is maintained by the various ocean currents. For example, the Gulf Stream, which basically comes from the Gulf of Mexico and goes towards the north of Europe, is what is keeping Europe warm. If you see the latitudinal extent of Europe and the Greenland, it is mostly at the same level. But Greenland is covered by ice, whereas Europe is mostly ice-free. So, because of the climate change, these polar ice caps are melting. And this melting is causing the changes in the thermohaline conditions in these regions. And this, because of the thermohaline condition, this entire Gulf, the ocean currents are continuously moving. Suppose this thermohaline condition changes and the water doesn't become dense enough so that it goes down, this entire ocean current may stop. This conveyor belt may stop. And if that happens, Europe can be like this, what we basically see in Greenland. And this is basically the changes in the Northern Hemisphere September sea ice extent. This is what model IPCC AR5 has told us that this entire sea ice is likely to melt. Apart from that, we have the various satellite navigations. I will not go into much detail, but there is one aspect where satellite navigation, especially for our IRNSS or NAVIC system, is playing a very important role. In 2007, we had the cyclone Oki in Kerala, where 70 fishermen who had gone out into the sea lost their life. Basically, the cyclone Oki originated in around south of Colombo, and then it moved towards the northwest. And it happened very, very fast. And the fishermen who had gone out to the sea could not be informed of the impending cyclone. So, and they also could not tell the people that they were in trouble, because in sea your mobile doesn't work. So we had extra IRNSS satellite in geostationary orbit, which had the ability to provide SMS signals. And this particular aspect was utilized to provide the fishermen, all the fishermen, a gadget which can communicate with their mobile through Bluetooth and can provide information through SMS for the impending storm or other things. In fact, now it has been modified in such a way that the people are also warned if they are basically going into the territorial waters of other countries, especially for Sri Lankan territorial water or Pakistani territorial water. Then we have the communication system. I will not talk much in detail about that. And using this communication system, we are basically providing the telemedicine to the remote areas as well as the areas which has been affected by disasters, where the doctors cannot go immediately. Another area which is very, very important is crowdsourcing and integrating this crowdsourcing HEIS platform. This during Chennai flood, this particular app was used extensively to identify the areas or the buildings which needed emergency response in terms of evacuation, in terms of relief materials or food, or in terms of medical exigencies. And the relief and rescue could be basically mobilized in those areas. And using this particular technology, we have also been able to use students from the various universities and colleges in Uttarakhand to collect the damage information from the field using an app which has been specially designed to collect this information. And in just a few days, more than 19,799 locations with all the information which you see in the right side of the screen could be collected and populated on the server. Then we have the National Database for Emergency Management, NDEM, which is, of course, is not free for general public, but it's accessible to the various stakeholders for various decision making. And this NDEM has a disaster dashboard. It has the ability for incident reporting, data visualization. It has decision support tools, and also provides an interaction portal to communicate with the people from the ground. So these are the types of inputs which you can have. You can prepare a proximity tool using this just a web-based system. You can do a network analysis. You can update various user-specific data and tools. And it also provides a multi-layer analysis. So India is part of the various international protocols for providing inputs for disasters, like in Sentinel Asia, which is international collaboration among the space agencies and disaster management agencies in Asia and the Pacific region. India is an active member and is also a member of International Charter for Space and Major Disaster. And this is a mechanism for providing space-based information for disaster response. So with this, I come to an end of my presentation. Thank you very much. So if we have any questions, we can have quick five minutes of questions session, and then I'll need to go. Thank you very much.
Thank you very much, sir, for such an in-depth and highly informative session. Forum is now open for questions. If there are any questions from participants.
Participants, please feel free to ask questions. Now this is a good opportunity. You are interacting a very senior scientist with a lot of practical experience. Don't hesitate, please ask.
If you would like to type your questions, you can type in the chat box.
May I ask a question?
Yeah, please.
So since you mentioned that there is now a national portal for disaster management and database which helps decision making. So can any independent NGO working in natural disaster management or maybe public health?
So presently this is accessible by various state disaster management authorities and the agencies or NGOs who have been authorized by the state disaster management authorities. apart from Ministry of Home Affairs and various units of ISRO.
I think students are feeling shy to ask question.
No, you can ask question, no problem in that.
I think Chintamani now nobody is asking any question, feeling shy.
Sir, I can ask one more question if you have time.
Yeah, please.
You spoke about the fire detection. Suppose forest fire is.
I am not able to hear you. Can you repeat it?
Can you hear me, sir, now? Can you hear me, sir, now?
Yeah, I can hear you.
So you spoke about the forest fire event. So any forest fire event occurs in any, let's say, any randomly any part of the country. So how we like in what time window we come to know through satellite imagery, or once it is reported from the ground report, then it is being studied.
See, actually, for observing or monitoring forest fire for the active fires, it is basically done through two satellites, or it's basically a combination of 4 satellites, of 6 satellites, 5 satellites presently. We have MODIS Terra and MODIS Aqua. We have the SNPP VIIRS. They are a pair of satellites, and we also have NOAA. So all of these satellites have similar sensors. Although MODIS, it's basically a bit old, so it has a coarser resolution sensor, but SNPP VIIRS and NOAA 20, they have similar sensors, and they actually they have a coverage of the entire Earth twice every day, once in the morning and once in the evening. So when we have 4 satellites, that is 2 of MODIS, 2 of SNPP VIRIS, we have basically 4 passes during the day. And whenever there is an active fire during the pass, this pass is basically at 10:30 in the morning, 9:30 in the morning by SNPP VIRIS, 10:30 in the morning by MODIS, then again 1:30 by MODIS, and something like 2 or 2:30 by SNPP VIRIS. So whenever there is a pass, and if there is an active fire, it is picked up. The detection is basically it's a contextual algorithm which runs, which as a layman I would explain that it highlights the pixel which has a higher temperature than the surrounding pixel, and then it's processed, and this information is provided to Forest Survey of India, which overlays it with the various administrative boundaries and sends the information as SMS to the stakeholders or the forest departments. So this information is provided 6 times every day by NRSC and then subsequently by the Forest Survey of India.
Thank you, sir. There are no questions in the chat box. If any student is typing a question, sir, we can pass it to you through Mathur sir.
Yeah, I would be happy to respond to them.
Thank you very much. It was great pleasure to have you, and I'm sure students have learned a lot how ISRO has contributed at disaster management. And I'm sure that students will get inspired to take up careers in this area. Thank you very much, sir.
Thank you very much. I'll now take leave because I have another meeting just now. Thank you.
Okay, thank you, Dr. Ajit, for accepting our offer at a very short notice.
Thank you, sir. It was my pleasure.
Yeah, nice.
Thank you, sir.
Okay.
Namaskar. Thank you, Jain sir.
Welcome, Dr. Rajkumar.
Good morning, Jan sir.
Good morning, Rajkumar ji.
Good morning.
You're welcome.
कहाँ अहमदाबाद आ गए कि अभी हैदराबाद में ही हो?
Just कल रात को आया 12 बजे.
Okay, very good. So very much definitely.
Great pleasure to have Mr. Rajkumar, who will be talking us about application challenges and opportunities in remote sensing and oceanography. And he is ex-director from NRSC ISRO Hyderabad. And sir, it's great pleasure to have you for this awareness webinar series for science students to understand opportunities in space sciences. So Dr. Rajkumar received his master's and PhD in physics from Lucknow University. He has recently superannuated from the post of Director, National Remote Sensing Center, ISRO Hyderabad, where he was leading the team of scientists from engineers from various disciplines with the mandate for establishment of ground stations, generation of data products, and dissemination to the users. Development of techniques for remote sensing applications, including disaster management support, geospatial services for good governance, and capacity building for professionals, faculty, and students. During 2016 to 2020, as Deputy Director in Space Application Center ISRO Ahmedabad, he had been instrumental in launching long-term programs in various disciplines of Earth system science studies such as hydrology, atmosphere, ocean, cryosphere, agriculture, and geosciences. Dr. Rajkumar has 39 years of experience and he has led the activities related to understanding Earth system, processes, and interactions using Earth observation data and its application towards social benefits, as well as studies in planetary sciences. During his tenure at Space Application Center, his major emphasis had been toward development of the quality products and availability to the community with new web-based analytics. He had also initiated and led the Department of Data Assimilative Ocean State Forecast Models for wave and circulations, which are in operational use at Indian Navy and other agencies. He has primarily carried out research towards the effective utilization of space technology, especially microwave remote sensing, for the studies of ocean, atmosphere, and climate for social benefits. He has more than 100 publications in peer-reviewed journals of international repute and has also supervised more than 10 young researchers for their PhD and still guiding young scientists. Dr. Rajkumar played pivotal role in propelling collaborations with international space agencies in remote sensing, also represented ISRO at alternate principal and international committee on Earth observation satellites. Considering his research contributions to the Indian science and excellent publications in reputed journals, he has been suitably recognized by various national awards such as Satish Dhawan Award, Hariom Asam Perit Vikram Sarabhai Award, PR Pishotroy Award, and ISRO Team Excellence Award. He's also a senior member of IEEE. So we are very privileged, sir, to have you today for this awareness webinar series. And sir, I request you to take over, and so we are very excited for your talk.
Thank you. Thank you, Chintamani. Just because sharing is, I think it is showing something is I'm unable to share.
Yeah, I think
I had to quit and reopen. That is showing like this. I don't know.
just
make it co-host.
is Dr. Veena there?
No, it is showing. I can share. It is showing, but I think because
It's done, sir.
yeah, I understand. But it is showing that whenever I go for sharing screen, the permission was not there, so I had to quit and reopen. Just 1 minute. I'll just quit and come up again on the this Zoom. I think Zoom was. You can hear me now?
Yes, yes.
You
We
can see
can
my
hear
screen.
you present. You make it a full screen.
Yeah, that I will do. That's what I was just checking. Mhm. It is there now?
No, no, not there.
Okay, I think slide show.
Rajkumar, extreme right.
Yeah. No,
Extreme
no,
right पे था. हाँ, now it's
Extreme,
okay.
extreme
Now it's
right.
okay.
no, it's okay. No, because now I'm using WPS, not the PowerPoint. That is the problem. Okay, fine. Thank you. Anyhow, good morning. I already wasted 5 minutes. Sorry for that. Yeah. Topic for my lecture is actually it is too broad if I say, because it is totally remote sensing as well as oceanography. I may like to maybe somewhat faster because remote sensing itself is a very broad topic and everything comes under the remote sensing what I will talking, and oceanography is actually part of that. Whatever we do, many themes we take in the remote sensing. Yesterday Dr. Mathur, Alok Mathur talked about, I think, meteorology, and then others. Just now Arijit was talking about the disaster management. So all things, whatever we are doing, I think space sciences for the application point of view, for the earth sciences, we call it a part of remote sensing. So whatever I will be talking about oceanography also from the perspective of the remote sensing, that is from the seeing from the satellite as well as the airborne or maybe the drone based remote sensing. So, and I think many of you may be knowing about the remote sensing, so I will not going much in the remote sensing itself per se, but a few things, maybe something, maybe duplicates also may be there. So if it is overall Earth observations, what we call it, there are many applications. So I will briefly, because the oceanography comes under these themes, all of these themes you can say. One is the overall Earth observation when we talk. One is the socio-economic security. In there itself, water is one of the major things. Water, energy, security. There also ocean is a part of that. I will come in the subsequent slides. See how this water and energy is part of that social security. And when another you might have heard in the all these talks nowadays when we are trying the climate science or the climate change, then sustainable development is one of the major theme. There are many 37 sustainable development goals, SDGs what we call it, are there, and many of these sustainable development goals are being served from the remote sensing. Not all, but we say when most of them are we can provide from this sustainable goal from the remote sensing, or maybe what we can say from the satellite based products. So in that also, when we say climate change impact, all of you, because you are a science student, you must have about the global change point of view. Sea level rise is one of the major global change scenario is there, and how this is sea level is increase is happening because of the ice melt from the polar regions, or maybe because of the thermal expansion also. So that also comes in the oceanography. That is one thing. And then just now what Dr. Arjit was talking about, the third pillar of this Earth observation application, disaster risk reduction. Here also, oceanography point of view, there are a lot of disaster point of view. You can say cyclone is there, and you method when the cyclone hits from the coastal side, there are a lot of damages are happening, and then we have high waves as well as the storm surge, which happens, which hits the coastal areas, and a lot of inundation happens. There also again oceanography takes a major role. And from the governor's point of view, also not as I will be coming that you might heard that Deep Ocean Mission. That is one of the major mission Ministry of Earth Science. It was approved last year itself from the government of India. Very very big mission. So there also oceanography. So all these pillars of the Earth observation, oceanography is the one of the major role. I can say plays a major role. Yeah, remote sensing I will not talk, but mainly what we say, the two types of remote sensing is there. One is the source is anything we want to sense. There should be one source. So sun is the one of the source for the many of this remote sensing applications, and then that we call it the passive remote sensing. You might have heard because the whatever in the satellite, you are not having any sensor for the sending the pulse or sending the energy. Whatever the energy is coming from the sun, that has been emitted from the ground, or maybe from atmosphere itself, and that has been sensed, that is being sensed by the satellite. So that is called the passive remote sensing. And then another is the active remote sensing, where the satellite itself or our sensor itself are sending the energy to the earth, and then we're taking back the scattering, what we call it, the back scatter. So those are the active sensors. So in remote sensing, these are the two type of sensors, what we call it. And during that, when we have interactions, I think yesterday what Martha might have talked about, atmosphere come in picture in a big role because a lot of absorption is there, emission from the atmosphere is there, and due to that only, by having different frequency or the wavelength or whatever way you call it, when we have the sensors, different channels or the sensors or different frequency, we sense the atmosphere also. And then by knowing the atmosphere, that is very very important. When I talk about the optical remote sensing, that is very very important part, how much absorption is taking place in the atmosphere. If you unless you know it very correctly, you cannot sense the earth surface. Remote sensing you can't do, because you will have a lot of emissions or absorption will be there in the atmosphere. You cannot characterize the surface, earth surface. So for that also we have various channels or frequencies in that anyhow Dr. Matha might have talked about, so I will not talk about that. So overall, if you say the remote sensing platforms, one is remote sensing. Normally it is being called from the satellite based remote sensing, because it's space based remote sensing, we call it different based on different satellites. But that is one part, because satellite can take a overall picture in the very fast, every 100-minute orbit in the polar region, polar satellites. So the every 100 minutes you get at least some part of the earth, that is repetitivity is there. But in addition to that, important remote sensing platforms are one of the important platforms is the airborne platform. Through that, what we do, we have the many sensors we flow on this airborne what is the aircrafts, so that we calibrate these sensors before flying on the space. That is one of the major things. And not only that, but sometime in disaster point of view also, these airborne sensors are very very important, or maybe the very high resolution sensors when we fly. So And National Remote Sensing Center has 2 aircraft for this purpose only. They are doing. In addition to that, these are the normally being done since many years, satellite based as well as the aircraft based, but new sensors, UAV based sensors. Since last year itself, you might have heard when the government has announced this policy of the drone based policy. It has opened up that policy, the drone based policy, when the policy of the geospatial policy also has been opened, meaning that all the data, whatever being collected at all the resolution, should be available to all the public. Some maybe some priced and some maybe freely available free data. But that time drone based earlier was very restricted data was there. Drone based sensors were very restricted. You cannot fly in many places. But now that policy is also there. So most of the locations one can have the drone based data. And this is also very important from the point of view if you really want to see some particular phenomena at a particular region. Because satellite will not be available each and every time. It will come on whenever this orbital pass is there, then only you can have it. But any like a disaster is happening or any particular phenomena, particular time you want to have it, then drone based things are very important, because you can fly at that particular time itself. At that particular location, one can go and fly these sensors. But disadvantage of this drone based is you cannot have a overall picture of that larger picture. So that is the reason. And then another sensors are the ground-based sensors. A lot of ground-based sensors are also there. So that's why when we do in the remote sensing, we do the combination of all those things. It's not we say satellite only can do, or aircraft only can do, or drone can do. This is not the case. Many people say drone can do each and everything, or satellite can each and everything. It is not the true case. If you really want to provide the solutions to the public, then you should have the combination of all these sensors. So that is the reason all these sensors are presently also existing in the whenever do any particular applications. This I think Arjit just now also talked. These are the different type of sensors what we have. I was talking about that. One is resource-based sensor, that is resource set. For cartography, we have carto set 1, 2, and 2 series and 3. For weather and climate, yesterday Dr. Mathur talked about INSET a series of sensors, megatropics. And for oceanography, basically we have a sensor ocean set 1 and then ocean set 2. These two sensors. Ocean set 1 was having ocean color monitor. I will be just coming about to that. And then ocean set 2 was an ocean color monitor, as well as the spectrometer sensor for the winds. And then we have a purely for oceanography, one is called the SARAL sensor, that is a radar altimeter, which gives the sea level, what I was talking about for the knowing the global change point of view, that sea level change, how to really monitor it, which is called the altimeter sensors. And then a lot of in situ based parameters are there, or in situ based sensors are there, which take these observations for the purpose of the validation of our sensors, of when we derive the parameter from the any remote sensing instrument, or this maybe the sometimes for different other purposes also, to get the long-term data for any particular region. So these are the sensors we have at different places. When you go in the oceanography itself, what we call it now, you people may be knowing, this is called the blue economy, because in India, coastal India is always from the all three sides. It is from the ocean, and almost we have a 7,500 kilometer of the coastline, and then exclusive economic zone. This is the region where we can actually have the resources for the particular country, any country. These have an exclusive economic zone also in the ocean. For Indian, we have almost more than 2 million square kilometers, where all the resources can be tapped by that particular country. So in that case, from the India point of view also, this ocean is very important. From the resource point of view also, natural resource point of view also, and for the monitoring of the various features. For that purpose, I was talking about that the Ministry of Earth Science last year have rolled out the draft Blue Economic Policy for India, which is having a lot of applications or maybe the impact on the livelihood of the coastal community, as well as the really monitoring the biodiversity in the ocean. As you read, beautiful places there in the ocean. If you go once and then you see the really in the somewhat below in the ocean, what is the natural beauty one can really observe. Yeah, so those are the biodiversity, as well as some of the resources, mineral resources, as well as many of the energy resources are there in the ocean. In addition to anyhow that national security point of view also, this is very, very important. So these are the area for the oceanography point of view, why any country should have this, why they are monitoring this, as well as from the India point of view also. You may have heard also marine fishery, when we call the potential fishery zone, what we call the forecast, what our country is doing since long. So that is one of the major applications we say in the ocean. But why we have the observation? Because as I was talking, surface observations from the ships or buoys are really not sufficient. You cannot have these things overall. Even whatever number of sensors you have, on whatever number of ships you can have, or the buoys you can have, but these are you cannot monitor or predict, have the prediction for each and every point. And then numerical models, what we call it, you may hear anything, we can call it the numerical model. Even y equal to mx plus c is one type of very simple model, we say, in terms of computer. But when based on the Newton's equation of motion, as well as different other energy balance equations, we have the numerical model. Based on that, we have the state of the ocean, we can know, or we can have the predictions of the ocean for the next few days, as well as the next climate point of view. But these are also not very accurate because of the for the knowing that that particular condition, you should have all these parameters should be known very accurately if you want to predict anything. So that way, those are also not very accurate. So this is the reason our satellite comes in the picture. So that is I was talking about advantage of the satellite is the synoptic coverage we have, and very repetitive coverage. One satellite itself have the repetitivity of the 10 days, 15 days at the same points. What Arjit was showing about one animation that how the satellite is moving in the polar region, in the polar orbit. So that is the one basic advantage, and some of the area which are not accessible by the ships or the buoys, because in the deep ocean, in the Southern Ocean, everything you cannot monitor each and every time, and certain parameters are available, like sea surface height. These are the parameters only available from the satellite. You cannot have you have the tide gauges, but only the near regions, coastal regions. But one of the basic disadvantage also from the satellite based is there, because it has the measurement only on the surface, or maybe a very certain layer of the surface, not very deep. So all the parameters are not available. That's why we have the combination of all these parameters, surface-based buoy, as well as ship observation, numerical models, as well as satellite-based observation. And based on these all three, we can derive all this three-dimension ocean observation, that is space-based observation. Then we call it in situ observation. And in the numerical model, what we do is the data assimilation. That means whatever data you are getting from the different sources, like from satellite or maybe from the ground-based data, that you put in the models, numerical models, so that your numerical models are able to have the better predictions. So that is called data assimilation. We call it simple word, we call it data assimilation, but there are a lot of many challenges are there in that. When we talk about the number, what type of parameter we can get from the ocean, from the visible sensors, which is one of the basic parameters, is the ocean color. Through that ocean color, whole biological oceanography as well as coastal oceanography comes in picture. I will be talking about briefly about that. Sensors are there, optical sensors are there. Through that, we have this all this information. Then another one of the important parameters, the ocean surface winds, which plays a major role in your weather forecast or the whole atmospheric circulation. Then ocean surface waves, which is the parameters which has what we're talking about, the energy, ocean energy. Then ocean surface waves is one of the parameters from the microwave. These are blue color. What it is bracket is the what type of sensors are being used for this particular parameter. Then sea surface temperature, very important parameter from microwave as well as infrared range of frequencies we operate. Then sea surface height, this is from the microwave sensor altimeter I was talking about. Then another very important parameter, sea surface salinity, what we call in the saltness, in the any parameter. In the ocean it's called the salinity, or in the land we call it the soil moisture as well. How much salt is there in the any particular feature. So that is these are the parameters important from the ocean point of view, and these we have from the satellite based observations. And it has the different when in remote sensing there are different resolutions. Some of you may be knowing. One is the spatial resolution, that is how much area wise, how much minutely you can see particular area, either meter scale, kilometer scale, centimeter scale. You can two different objects can be distinguished. That's called the spatial resolution. Then comes the spectral resolution, where we have the different frequency. What I was talking about in the right hand side is the electromagnetic spectrum. How you can divide these frequencies and have observation your sensor at that particular narrow channels, narrow band channels. So that is called the spectral resolutions. Then radiometric resolution, how much sensitivity of each sensor is there in terms of the degree Kelvin, you can say, or the back scattering point of view dB. So that is radiometric resolution. And temporal resolution at how much after how much time any particular parameter is being observed. Either maybe you can say like atmospheric parameter every minute, every half an hour, every hour or something like that, or in the polar orbiting sensor every 2 days, 5 days, 10 days. So that is a temporal resolution. So these are the different type of resolution when we talk about this any sensor, and how this all these parameters what I was talking about, how these things we can do from the satellite, because the satellite suppose is having one frequency only, or one channel we are observing, or maybe the broad channel we are observing from the satellite. We are a total energy is coming from the ocean, but how we can say this is parameter is giving the salinity, or this parameter is giving the wind speed, or the water vapor, or sea surface temperature. But for that purpose only this particular slide is there. It shows that sensitivity of a particular parameter with the any visible observable parameter, like I was talking about the temperature, brightness temperature we can say, or scattering coefficient, that is delta TB upon delta PI is the delta parameter, and TB is the brightness temperature. So sensitivity of the brightness temperature to particular parameter for particular frequency. So that has been shown. If you see in that for this sea surface temperature, you see around 6 gigahertz, around 6.6 gigahertz. That is the highest sensitivity is there. After that, other places the sensitivity is low. So that means if we have your sensor you design for that particular frequency, then that sensor will be having more sensitive to the for the sea surface temperature. But for other parameter also will be having impact, like the wind speed. If you see, some impact of wind speed is also will be there on this channel. So that means you should have this channel plus other channels also, so that if you want to derive the sea surface temperature from this any particular sensor, so that will be more sensitive for the sea surface temperature, but effect of wind speed will also be there, or water vapor also will be there, or many salinity will also be there. So you have to remove, if you want to remove all these other parameters, then you should have those channels also. So that combination of these channels, you can get that particular parameter. Similarly, for salinity, if you see, it is almost at the 1.2 gigahertz or 1.5 gigahertz, it will be higher sensitivity. But if you have a channel 1.5 gigahertz, you will have the impact of the wind speed also, you will have the impact of sea surface temperature also at that when you are having the energy from the ocean. So to get the accurate of sea surface salinity, you should remove all these other effects. So if you are having 2-3 channels, then by having combination of these 2 channels, you remove the impact of other parameter, and you get the higher accuracy of this particular. That's why we have the different frequencies when we talk about all these sensors. They operate in different frequency, not only one but many frequencies, so that you have the observations at or the very high accurate parameters. So overall, this is the application wise when you get the data, how you get the actual your from the application point of view, how you get the overall parameter or your solution for that. So for that purpose, you have the data, then you have the optical data, or maybe multispectral data or multi-temporal data. From that on the earth, you have the digital elevation model, so that you remove that whatever the elevation features of earth, and then you have the all other in situ data. Based on all those things, you generate the ortho image, and then as I was talking about combination of these sensors, you derive the different parameters, and this information you convert, because this also information may not be useful. If you say any particular layman, he may not be knowing what I will do with the sea surface temperature or what I will do with the salinity. So this information based on our knowledge or our experience, we derive the particular knowledge, then how it will be useful for particular purpose or for particular application. So that information we convert to the knowledge, and that is being provided by us from the space scientists, as well as from the scientists from different ministries to the actual user. It is being provided. So this is the overall gamut of how these things are being done. If we see the different applications or from the detection, how we do these parameters. So mainly one of the parameters is the reflection and absorption. I was talking about the water in optical region. By absorption as well as reflection in the optical domain, you delineate the different parameters like chlorophyll, sediments, how much sediment is there, what type of sediments are there, turbidity in the water, as well as the NDVI, what called the vegetation index, normalized vegetation index. Then another parameter of the similar to absorption is emission in thermal infrared, that is the infrared region. From that you get the sea surface temperature as well as the land surface temperature, and other parameters in the atmosphere like rain, etc. Then in the back scattering in microwave region, that is the active sensors, we get the parameters like ocean surface wind, ocean surface wave, oil spill monitoring, salinity, and how much water is spread delineated when in the case of the even when cyclone is there or rain is there, or overall how much water in any particular lakes are there. Those things, or the rivers, that is being monitored. In the passive micro emissions, we have the salinity, we have one of the parameters, and then sea surface temperature, winds. So like this, based on this, what exact parameter you want to know, we have the different bands in the electromagnetic radiation, and we do. Yeah. So in optical, I was talking about that how you define the ocean, what is called the ocean color. If you see these beautiful pictures on the right hand side, these are the pictures from the camera. You can see very different pictures, different blue color, yellow colors, as well as a green color, or sometimes black colors. Also ocean, what you see, and these are the combination of, because of the different features in the ocean, because of phytoplankton may be there, sediments may be there, or maybe the CDOM, what we call the color dissolved organic matter, is there. So those things one has to really quantify, because by seeing the only from the camera, you cannot quantify this, how much CDOM is there in the uh, ocean, or how much phytoplankton is there, because these parameters give the go for the application different, like what I was talking about, the fishery forecast, or maybe the different type of phytoplankton, algal blooms are there. So if you really want to quantify, then you should know how much it is there. And for that purpose, based on the emission, as we were talking about, and remote sensing, somebody might have told about also, based on the different frequency, you have the absorption of all these parameters. And then these parameters are like, this is the right hand side column, you see the different channels what we are having. And this is the 20 nanometer, what you calling the, I was talking about the spectral resolution of the particular channel. So based on these channels, you can get the number of different applications like yellow substance, chlorophyll, and whether high is there, low chlorophyll is there, or sediment is there. So and then last two channels, this is OceanSat 2, eight channels. So last two channels are the for atmospheric correction, very important parameter, because when you are coming getting this radiation from the ocean, you are getting very actually feeble signal from the ocean, because most of signal itself is from the atmosphere also. So you have to characterize that atmospheric turbulence or atmospheric water features are there, different type of atmospheres, aerosols are there, or so this has to be defined accurately. You have to measure these atmospheric parameters, then only you can get the really the ocean these parameters, what you call it, very accurately. So yeah, and this is you can see I was talking about the how you see the different type of waters from the camera normally see, and this is just now from this any particular spaceborne sensor. So different regions, what we wanted to show, different type of water is in the near Ahmedabad. This is a black color you are seeing in the different channels. Then it is a green color, and then a blue color. Based on this, I was talking different parameters in the, or different constituents in the ocean, or any water is there, because the chlorophyll, turbidity is there, or the eutrophication, how much is there. So based on this different channel, we can get the actually the water quality also, which is very important. Not only the water extent of the water, or not only the chlorophyll, but the quality also. If you have really all those required channels, and then if you have the very narrow bandwidth like hyperspectral, then these also can be done from the spaceborne or the airborne sensor, and then we can define the how much whether water is very good point of view of the for the human or not. So that we define, and this is the this is the water quality. Again, you see the top different color from this photograph, and then the middle section you see from this hyperspectral sensor, what we call it, very fine channels, nanometer spectral resolution. So 1, 2, 3, 4, what is written at particular wavelength. If you see at this left hand side from the hyperspectral, which region, how sensitivity of this particular channel, or how much reflectance is there. Based on this, if you see at that around when we are talking about the around 550, if you're having only one channel 550, then you can see there are many channels are having a similar reflectance. So that parameter, if you want to really define a particular parameter, then you should have the combination of all these channels, and then you can derive different all these different parameters even in hyperspectral also, and then you can see the water quality can be defined. So these are the just one of a few of the applications for that. And this is the one of the sensors I was talking about, OceanSat 1. This is what and OceanSat 2 also, which is having the ocean color monitor. So through that, we derived a number of parameters like chlorophyll, total suspended monitor, suspended matter, and then aerosol optical depth, which defined that how good or bad is the actually aerosol in the atmosphere. And based on this accuracy of this AOD, we can derive this chlorophyll and TSM or CDOM, different parameters. So these are the very good accuracy we can derive in the actually the open ocean, but a lot of challenges are in the coastal ocean. The coastal ocean, that water itself is so much having different methods. So we have to have some other channels also for defining these other parameters. That's why in this new, that's why we are having so many channels in the OceanSat 3. We have increased the number of channels. These are some examples of the OceanSat 1 and 2 of this mangrove in the Sundarban area. You can see the very beautiful colorful pictures of the Sundarban area. But really, as I was talking about, if you really want to quantify with the accuracy of, if you say the 90% accuracy or 80% accuracy, then you should have all these channels. Otherwise, deriving these things is very, very difficult in this thing. So based on this, whatever the products I was talking about, the different parameters, there are a number of applications like potential fishing zone forecast. It means since almost 20 years it is being done, and now it is getting more and more improved forecast for these regions in the coastal as well as the open ocean region is being given by Ministry of Earth Science. Earlier, this technique itself was developed in Space Application Center, Ahmedabad, and then it was transferred to the INQUIS, Ministry of Earth Sciences. And initially, only the temperature was one of the parameter based on the temperature front. These was being derived, but now sea surface winds or sea surface sea level, these are the other parameters also are being included in those things. So forecast is being improved. And then primary productivity, as well as the very, very important biogeochemical cycle, how this overall mixing is taking place. For that also, you should have information of these parameters. And sedimentary flux, algal blooms I was talking about, and productivity when the cyclone comes in the ocean, productivity increases during that time. So that is also how this productivity increasing. So these things, all these things are the different, many other applications are there in the oceanography point of view from this ocean color, that is the visible sensor itself. And I was talking about that the challenges, yeah, retrieval for optically complex water, that is in the coastal region, that is very, very challenging still also, and that is actually a very good area for all these students also to work into that. What exactly should be there, or if any algorithm have to be developed for this purpose. One thing is algorithm development. Other thing, what type of sensor development should also be there. What exactly type of sensor should be there, and really, if engineering point of view, if you see development of that optics as well detectors, that is what is being done. So those also are challenges. Still, there are a lot of challenges in these areas. For the sea surface temperature, I was talking about this is since long is been done based on this infrared as well as the microwave, not only from the polar orbiting satellite, but from the satellite of this geostationary satellite also. But only disadvantage of geostationary satellite is there. You will have the actually very coarser resolution. That is the not very fine area you can get the sea surface temperature. But the overall scale, coarser scale, you can get the sea surface temperature. That means this is the but advantage is there every now and then. That means every half an hour you can get the observation of the sea surface temperature, and then you can get the variability in the daytime variability, nighttime variability. All those you can have the geostationary, but resolution will be poorer. Whereas the other way from the polar orbit satellite, you have the higher spatial resolution, but temporal resolution will be poorer. So combination of these things are being used to derive the sea surface temperature all over the globe, and then this maps as well as the data is being provided using these sensors. So these are the applications, how this sea surface temperature had applications really in the case of the cyclone, one of the major, because still around the 26.5 degrees centigrade, if higher is the temperature, then probability of cyclone will be, generation of cyclone will be higher. That is one of the criteria we say is, as well as the, you might have heard that overall temperature rise is also happening. So that monitoring of that, if you are having a regular monitoring, that can be done, as well as the impact of these things or the biogeochemical cycle, one of the major parameter from the global climate change point of view. And one of the other parameter or the application of is the, what you heard is the monsoon. Sometime it is we are telling that monsoon will be poorer, or maybe the monsoon will be good based on the El Nino or La Nina cycle in the, and that is based on the, basically based on the sea surface temperature only. So this is one of the important parameter, not only from the oceanography point of view, but from the atmospheric point of view, as the climate point of view also. So those things are being a number of applications from this. And when I was talking about different type of sensor, now we'll be talking about. So one is the sensor, radiometer sensor. These are passive sensors are there. In that, many passive sensors are there. These are some of the list I was talking about. One is the scanning radiometer is there, which gives the sea surface temperature, wind speed, water vapor in the atmosphere, all the parameters. And like fourth row, you see Aquarius is that for the sea surface salinity. I was talking about now, the sensitivity of sea surface salinity is around 1.2 to 1.3 gigahertz. So that type of sensors are there for the sea surface salinity. And SMAP is also similar sensor for the soil moisture as well as the sea surface salinity. So these are the number of sensors are there for the in the radiometer range. And salinity, this I was talking. This very a very important parameter of the type is the saltness in the water. For the total circulation in the ocean, like atmospheric circulation, you have the overall wind circulation or the water vapor or humidity in that ocean. Because of this ocean currents, how they propagate in the deeper ocean also, and propagate in the all the from the southern pole to the north pole, going from the Atlantic Ocean and Pacific Ocean coming. The salinity plays a very important role in that. And when we take the measurement of salinity, because salinity is not that much changing in each and every place, so to measurement of those, you should have that accuracies or inaccuracies what we are coming, that errors, because you should know the atmosphere very accurately. And then 1.2 gigahertz, because ionosphere is also playing a major role. So you should know the how the changes in the ionosphere is there, and other parameter of the ocean also. So when we derive these parameters, looks like that very easy, that if you develop a sensor at a particular frequency, you can derive particular parameter. But because of the other many other factors, atmosphere as well as that ocean, or when you're talking land, that different features of those things play a major role. So you have to remove those effects, and then only you can get the particular parameters. So similar, these are some of the sensors like Aquarius, soil moisture, SMOS sensor, and SMAPs radiometers, which are continuously some of these. We are providing that earlier also, that sea surface salinity maps, and now some of them are still working, and they are providing regular. This is from the micro radiometer, SMAP radiometer, how much you can derive the sea surface salinity. This is some of the work we did here itself. And then from this second, the Argos is from the ground truth, what we call it. Ground truth versus what we derive from the satellite. How good those things are there based on this. So these are the research area, what we call it, is being done by us also, and can be done by all of you also, because this is the all those things when we are talking about atmospheric ocean, these are the very challenging area, and always go on. Improvements are going on since long, and still a lot of improvements are required, and for many areas in this. Similarly, for this when active sensor, what we call it, three type of sensors are there. One is the altimeter. I'll briefly talk about that also. Altimeter is there, which gives the from the nadir you get the measurement. Another sensor is spectrometer, which is looking from the angle to the ocean or the land. Third one is synthetic temperature radar, similar to spectrometer, but gives the very high resolution pictures. So these are the basically active sensor, because they send the pulse and then get the parameter from the ocean, like ocean waves, ocean winds, ocean currents, sea level, and some derived information like ocean depth, oil spill, ship speed and direction. So based on this, which direction you are seeing, you see blue arrow and red arrow you are seeing, based on which direction you are seeing that ocean, and then based on the roughness of the ocean, how much backscatter energy you get, and that energy you convert to the different parameters like how much ocean surface winds are there, how much ocean currents are there, or how much high waves are there that we derive. This is the simple diagram for the ocean radar altimeter, where it looks down directly. If you see the right hand side picture, it looks down from the sensor. We send the pulse, and that pulse comes back to the satellite, and then based on this, we get the sea level. It looks very, very simple that we are sending a pulse and getting back like anything measurement. When you send a laser light, you send a pulse, and when it reflects back, you get the total and time difference. You can get the sea level or the distance. But as I was talking earlier also, but in this sensor, it is very, very important the other parameters or other inaccuracies what are coming because the ionosphere, because or atmosphere, or because the ocean itself. Because when you're talking, you are seeing from the almost 800 kilometer or 1000 kilometer, and you want to know the accuracy in the millimeters or the centimeter scale. So you can understand how much accuracy is required in measurement itself, orbit of the satellite, as well as the whatever the inaccuracies are coming because of the atmosphere itself. So because of these are the regions, we should have the very, very high precise orbit, high precise altimeter, and that other sensors, some ancillary sensors to derive the atmospheric parameters, as well as the geoid, that is the ocean. When geoid is also there because of the it is not a spherical surface in the below the ocean, and then you have the anomaly will be there, geoid anomaly. Due to that also, your height variations will be there. So all those things are important, and those are the all things which makes it very, very challenging sensor. Looks very simple, but very challenging sensor, as well as the challenging parameter to derive this sea surface height. Then based on this, we get sea surface height. Another parameter from this, we also get the ocean surface waves, ocean surface wave height, all over the sea level. Sea surface wave height is there, and then and based on this, you can clearly see that how good is the satellite altimeter data nowadays is providing the sea level, global mean sea level. Otherwise, from the tide gauge data, you can't have that much. Each and every location, you can't have the sea level. But from the altimeter data, you can have that very, very highly accurate sea level data, and then you can, based on these predictions, are being done all over the ocean. And this is the mean sea level from the earlier years, based on the altimeter data itself. You can see from the different satellite, like starting from Topaz, JSON 1, 2, 3 series is there, and then SWOT satellite is also coming. And altimeter is one of the major sensor for the oceanography point of view, because sea level you cannot get from any other sensor. So this is the what we are talking about, how much sea level changes is happening in the region. And this is the one of the altimeter I was talking, Altica altimeter, which was the French and India joint collaboration was there. From that, we get a sea surface height anomaly. So ocean wave height as well as the wind speed. These are ocean parameter. But in addition, we also have the parameter in the polar region, that the sea ice thickness. That also we derived. And one of the parameters what we did for the Indian coastal regions, because this is normally for the open ocean, but coastal regions products were derived by us and being provided to the everybody. And this is a sensor what I was doing is SWOT sensor, because altimeter is a sensor which is a very, very narrow range, narrow swath. That means the 2 kilometer or 5 kilometer only area it covers, because it sends a pulse. So you should have a many 5 or 6 altimeter itself if you really want to have the overall measurement. But in this case, so that's why SWOT this concept came, which gives the large area coverage, almost more than 100 kilometer, with the total altimeter SWOT is there, carbon altimeter is there. From that, we will be able to have this is a high what you say, the SWOT, larger SWOT altimetry for the ocean as well as for the land also. That means of river level also we will be having the all these levels. So this is SWOT altimetry. Then because the time is not there, I will talking about this few more sensor. This is a spectrometer sensor I was talking about. This is the, it is gives the wind speed as well as the direction. This is the one of the sensor. Altimeter looking down, but just look at the particular angle. You can say 40-degree and 50-degree angle approximately. And based on this angular variations at different angle, it have the measurement of the ocean. And then by phenomena, what we call the Bragg scattering from the ocean surface waves, we get the back scatter based on the how much roughness is there on the ocean. And roughness is basically because of the wind. Because as wind blows on the ocean, you get the more and more rough ocean. So that is the concept or understanding. Based on that, we derive the ocean surface wind as well as the direction, because we are measuring from the different angles. You can see the two antennas, the other are green and red. They are moving. This is a rotating antenna, what we call it. And based on this, the two antennas, two polarizations are the horizontal, vertical polarizations. We get each and every place we get the number of observation, and based on the number of observations, this satellite moves, and then around 25 kilometer, each 25 kilometer, 25 kilometer area, we get the wind speed and direction. But we derived the methodology. By this methodology, we can have the somewhat more higher resolution also. That means we can go up to 6 kilometer by 6 kilometer resolution, wind speed and direction. So that is still a coarser resolution. If you see, it is not very high resolution. So, but even then, this is another cartoon. That is why we get the wind speed and direction both. So if you see in the right hand side, measurement is taking place at different angle, and then sensitivity of the sigma 0 backscatter based on the wind speed and different angle. So that is the reason if you have the different angle measurement, then you can get the high sensitivity of the wind speed. That's why we have around 50-degree angle. That means for the small change in wind speed, you get the large change in the scattering coefficient. So based on that, we derive the wind speed as well as the wind direction. And these are some calculations we do to derive. I will not go much detail. So based on those, all these calculations, we derive the wind speed as well as wind direction from the spectrometer sensors, or what we call it. This is our spectrometer OceanSat 2 and ScatSat 1, which was there till the last year. It was launched in 2016. And now we will having a OceanSat 3 spectrometer, sea surface temperature monitor, as well as this ocean color monitor. All three sensors will be there. And based on that, we will have all this information what we were talking about, that related to the potential fishery zone, as well as the sea surface temperature related information, and the wind speed and wind direction information. And this was the sensor, what we call it, the since so many years, almost 5 years, we had continuous observations, and then accuracy was so good, we can call it the climate quality observations based on that sensor. And not only the wind speed and direction at particular level, but all over the globe, we could able to provide. And these are some of the applications area like storm surge, upwelling, and shipping safety. These are some of the applications we could do using this sensor. Then the last sensor is the synthetic aperture radar, because I was talking that a spectrometer gives the area 6 kilometer, 5 kilometer resolution only. But synthetic aperture radar is one of the sensor. By synthesizing the aperture of the antenna, you can get a very high resolution. You can get the resolution of the 1 meter, 2 meter, like that. So I will not go detail about this how we get it, but this is the one of the advancement in the technology by synthetic aperture. you can get the very high resolution. And we had a few sensor reset 1 earlier was there, and you might have heard the last year we had RSat 1A, which is similar to RSat 1. Through that in ocean, mainly for the land features. But now we have for this ocean also so many parameters. We are having like ocean wave spectra, internal wave bathymetry, many parameters in the ocean also we are able to get. And then based on this, you may be hearing in the newspapers or maybe the other reports. NASA and ISRO are having developing one synthetic aperture radar. NASA ISRO synthetic aperture radar, NISR, which is a dual frequency synthetic aperture radar, L band and S band. S band by India, L band by the NASA, and then ISRO will be launching it maybe next year, end of next year, where it is polarimetric sensor as interferometric sensor, one of the best sensor we can say in synthetic aperture radar, which is being developed by both of India as well as NASA. Very high resolution, very large swath. Both the ways this sensor is will be the one of the great sensor, which will give the number of thematic observations or thematic application like ecosystem, like the forestry, agriculture, land deformation point of view, how much from the earthquake point of view, how the land deformation is happening, or maybe the subsidence is happening, cryosphere application, coastal application, disaster point of view, and many geological applications. So this is the one of the sensor we are looking forward, and we will be really looking for that. And some of the scientific objective of this is the really the understanding the response of the ice sheet and glacier from the minute level, how much changes are happening in the glacier region, and then how much carbon storage is there and uptake in the wooded and agriculture biomass. So these are some of the things we are looking for the NASA ISRO synthetic aperture radar. These are some of the applications of the synthetic aperture radar from the ocean point of view. Very high resolution winds as well as the wind power point of view. Also in the coastal regions, we were doing some experiment, as well as the coastal bathymetry I was talking about. Internal wave, one of the very useful feature for to know the how much total energy is propagating from the internal waves. That means density stratification point of view. And these are the last the overall ocean energy point of view. Also, these sensors are very important from the ocean wave energy, ocean tidal energy, ocean thermal energy, and the ocean salinity based energy. That is the total how much energy is available. So these things are being done by us. And the last, as initial itself, I talk about, we do all these experiments using the model, that numerical models, satellite data, and in situ data, and then we assimilate it in the numerical model and validate through the in situ data, and then provide the all these predictions for the ocean in the not only the surface but as the different layers also. Like in the ocean models, we have the wave model, circulation model, biogeochemistry coupled model at different resolutions. From the very coarser resolution in the global scale, that 25 kilometer, then we go the high resolution in the 10 kilometer or 2 kilometer resolution in the Indian Ocean, and then the very high resolution in the regions of the approximately 100 meter by 100 meter as specific area. Through that, we do number of experiments using the data assimilative models, and we provide to the different users, and for even for in-house applications also, we do all those things. Not only the surface, but different layers of surface. I was talking about the how the overall structure of the 3D profile of the ocean is there, density profile, current profile, temperature profile, all those things also using this model we are able to do. So this is the profile, and this is how we do the different experiment in the data assimilation, and then define the different even the sensors also, which type of sensor or what is the sensitivity of sensor should also be there. Based on this, we design. And then this the coastal applications. We have an inventory and modeling of the coastal zone, coastal sediment I was talking about. Then we derive all the coastal shoreline changes as the coastal zone management point of view, how these things are happening in the coastal oceanography. These are some of the websites from the ISRO. Most of you might have seen. One is the site from the Bhuvan, which is the number of applications. MOSDEC from this lecture point of view, Meteorology Oceanography Satellite Data Archival Center, which gives a lot of information. You should visit this site, and then you should see what number of information, number of products are being available, and number of applications are being given. Thank you.
Thank you very much, sir, for such a highly informative talk. You really went to in-depth in measurement of all the different kinds of measurements of remote sensing and oceanography, which I'm sure students should have really enjoyed, and which will trigger interest in them in the field of remote sensing and oceanography. With that, forum is open for questions. If there are any questions uh, from participant students, uh, we can take those. Are there any questions from participants? Students can, it is my request to students that they can ask questions in their mother tongue also. Don't be shy, and your professor can translate it for the speaker. Sir, I have a question. If there are any research institutions or academic institutions having interest in analyzing weather data, how they can collaborate with the agencies or any even startups interested in this kind of work, contributing in the analysis or even sensor or instrument development?
Yeah, very good. Actually, sorry, actually, I missed that part. This is the advantage of the oceanography and meteorology. This data is mostly open. All this data is open, and that's what I was talking in the site, MOSDEC site, we call it, Meteorological Oceanography Satellite Data Archival Center. There also, all the data is open. Everybody, any student want to take the data. Some data is directly available. Otherwise, they can register through our site so that we know what type of data they are using. Registration only for that purpose. They can register, and then they can start getting the download the data. Otherwise, also for visualization, everything is available for them. And they can always come to us through different projects, through Respond or maybe the collaborative project what we have in OceanSat 3. Also, we'll be having some of the projects we are opening up, so they can participate in those. Even not students, but their faculty members, they can send the projects for proposal to us. Then we can take them in those projects also, so they can work with us. And for them, it is good learning also, and for us, it will be good hand to train them. For that also, we have many training programs also for this purpose, so they can always come with them.
Thank you very much, sir. Are there any other questions?
If you are having any problem, maybe if you are hesitant to ask question, maybe happening, you can always write to us. Even personally, also you can write to me also. Anybody, any member of us, we will really glad to reply to and help you in the what type of things you want to career you want to take in this, and what are the challenges, which areas are research areas, because this in one our talk you may not be able to understand what is the research overall research area. That also we can help out and tell to you or the faculty members also, which are the projects you can take, which are the data you can work on, which are the areas where future is there. That also is.
Thank you very much, sir. It was great pleasure to have you, and uh, uh, it was we are very fortunate so that we could uh, attend your talk, and it was really highly informative. Thank you very much, sir.
Thank you. Thank you.
So we have next talk on application challenges and opportunities in optics for space research and applications by Dr. Shashi Kiran Ganesh, who is Associate Professor at PRL Department of Space. Has sir joined?
Yeah, Chintamani ji, I'm here online.
Okay.
Let me switch on the video. Yeah. So can you hear me?
Yes, yes, sir.
Okay, great.
So,
Should we test the screen sharing now? Or?
Yes, sir. May I request, before sir, we start the session, may I request Ms. Meera Deshpande, Assistant Professor at PC Jabin Science College, to officially introduce our current session speaker.
Thank you, sir. Good afternoon, everyone. I take an immense pleasure to introduce Dr. Shashi Kiran Ganesh to this audience. Sir has completed his bachelor's degree in science at St. Xavier's College, Ahmedabad, and master's from Department of Physics, School of Sciences, Gujarat University. He joined PRL as a scientist in 1997 after completing a PG diploma in space sciences and applications from Gujarat University. His interests range from solar system studies to active galactic nuclei. He has also worked on building astronomical instruments at PRL and has set up India's first automated robotic telescope at Mount Abu. He has more than 75 referred publications to his credit. He is a part of the ISOGAL team, which produced a catalog of over 100,000 new mid-infrared stars towards the galactic plane using the Infrared Space Observatory. He is a recipient of the URSI Young Scientist Award and also a two-time recipient of the Marie Curie Fellowship. Currently, he is involved as principal investigator in developing an instrument for near-infrared imaging, spectroscopy, and polarimetry for PRL's new 2.5 telescope at Mount Abu. With this brief introduction, ladies and gentlemen, I present before you Dr. Shashi Kiran Ganesh. Thank you.
Thank you very much, Professor Deshpande ji.
Thank you.
Can you see my slides? Is it?
Yes, sir, it's visible.
Okay. So thanks again for the opportunity. I would like to especially thank Alok Mathur ji and Hariom Vats ji for inviting me for this lecture and giving me an opportunity to talk to you all. So what I shall do in the next 35-40 minutes is to try and tell you about the challenges of optics in space from the perspective of an astronomer. See, I'm basically an astronomer, not really a space scientist. So I work mostly with data from observatories, which are both on the ground as well as in space. And I have also been building instruments for telescopes which are on the ground. So I'll just share with you some details about what it is like to be observing with our Mount Abu Observatory. Because not many of you, especially the students, would be aware of these facilities which we have within the country for really front-ranking research in astronomy. So to start with, we have this 1.2 meter telescope. It's a telescope which was built by ISRO in the 1980s and 90s, and it's quite functioning very well. The main reason being that we have a host of instruments on it. So this is the telescope here, and I'm not sure if my pointer is visible. Okay, probably not. The structure on the left side is the telescope, and then the golden stuff at the bottom is the backend instrument, And this backend instrument decides what we are going to do with the light collected by the telescope. Okay, so this backend instrument can have multiple different types. Like we can have spectrographs, we can have polarimeters, or just simple imaging cameras. Okay, and depending upon what kind of detector is used, we'll be looking at different wavelengths. So these are the facilities which are available with our existing 1.2 meter telescope. But in addition to this long-running telescope, which is the first infrared telescope in the country, by the way, so we have many other new telescopes which have joined hands. We'll come to that in a moment. So here we are showing just one of the other facilities, auxiliary facilities, which we have with the telescope at the observatory site. And that is how we aluminize the mirror of the telescope. So here from the people in the picture, you can judge the scale of this size of the mirror. So this mirror is actually sitting in the blue drum-like feature here. Okay, so once in a couple of years, we remove it and remove the old polish and put a fresh coat of aluminium in this vacuum chamber. So those are the kind of things that we need to keep doing on a regular basis. It's a very challenging exercise because the mirror has to be packed in a box and brought down by crane over 3 floors, and it's all done by hand. So here we have a view of a panoramic view of the observatory site. So the center one, the big spherical dome, is the 1.2 meter, the old one. And we have towards the left of the picture, we have 2 different telescopes of 43 centimeter, which is again at the center of the bottom center. And we have a 50 centimeter robotic telescope, which is shown on the left side. On the right side, in both the pictures, you see the building labeled 2.5 meter. So this constitutes the second largest telescope in India currently. The installation is in progress, and hopefully we shall be able to start using it from the coming observing season. So with this brief introduction about our facilities at PRL, I would like to suggest that those who are interested, please look through our website and look up all the details. Unfortunately, I can't go into more of the details about this. Maybe if there are questions, we can discuss further. So what am I going to talk about in this next few minutes is about how we use optics in space and how it all started. And why do we really want to go into space in the first place, right? You can always look at the stars from the ground. So why go into space? So that all starts almost with many, many different science topics. It starts with Newton and his treatise on optics. And he showed in that light constitutes of is constituted of various colors. Okay, and this was the origin of our understanding of the electromagnetic spectrum. So this electromagnetic spectrum constitutes of again, as Maxwell has told us, from electromagnetic waves right from over a long range of wavelengths. So what happens to those wavelengths? I think you might have seen this particular slide from many speakers yesterday and today, but I thought I'll just show you from the perspective of astronomy. So when we look at things in the optical with the human eye, we are looking at a very small range, which is the region in this part, which is visible to the human eye. And this is the part which reaches the ground. Okay, the atmosphere otherwise absorbs all of the gamma rays, X-rays, and most of the ultraviolet. And even in the infrared, you have a lot of windows, but then it is best observed from space. Radio waves are observable from Earth, and GMRT from India is one of the prime examples of such an observatory. It's the biggest observatory on the Earth at those wavelengths. Okay, and then going further, even the longer wavelength radio waves are blocked. So essentially, it means that if you really want to have a full idea of what is happening in the universe, you need to really look at all of these wavelengths, right from gamma rays to radio waves. And the only way to do that is by launching telescopes with appropriate detectors into space. Okay, so to show you what I mean when I say that we need to look at the universe in all wavelengths, let's just have a quick look at what the Milky Way looks like across the electromagnetic spectrum. So at the top, we have the radio continuum band, and right at the bottom, we have the gamma ray. Okay, somewhere just the third panel from the bottom is the optical window, which is what we can see in the night sky as the Akash Ganga. So Akash Ganga, if you see very closely, it would be, you will see that there are actually two bands, and there is a dark patch running between those two bands. Okay, especially in June, July, August, if you look up at the night sky, you will see it very distinctly, at least if the monsoon clouds allow you. Okay, now these black patches are because of dust, which is blocking the light from the background stars. So the moment you go to higher wavelengths, longer wavelengths, the dust becomes transparent and you're able to see the stars. So as you go to longer and longer wavelengths, you start seeing more and more different material. Okay, so this is a reason why we should go to space. Okay, what happened? Yeah, so this is another example. I think many of you would have, oh, by the way, if there are any questions, please ask me in between. I don't mind being interrupted, okay? And I hope the connection is still stable and going through. So in this picture here, on the left side, we have a view of the Orion region. So I think many of you would be familiar with this part of the sky. You see it in winter nights early in the evening as the three belt stars, okay? And if you look at this in different wavelengths, this is what you would see. With a larger telescope and long exposure images, you will start seeing this kind of cloud patterns around it, as shown in the blue panel in the center, above center, okay? Over in the next one, we see how the same area of the sky looks like in the microwave and submillimeter. And these were images taken by the Planck satellite. Okay, I shall not be talking about Planck, but then many others we'll discuss. So mid-infrared, for example, shows quite a different view of the same region. This is a small patch of this orange spot as shown in the image on the left. Okay, and the same region, if you look at it using visible and near infrared imaging equipment, like from the Hubble Space Telescope, then you see that it's quite different. In fact, even at near infrared, you see a lot of dark absorbing material which starts radiating the moment you go to longer wavelengths. Okay, so what? So I think I have convinced you that we need to go to space in order to observe the whole universe. So let us look at some of the examples of the telescopes and observatories which were launched into space and what kind of things we have learned from them. Okay, so I have another 20-25 minutes or so, something like that. Let us get to it. So for example, with the Hubble Space Telescope, we will discuss what kind of challenges and results we found. And see, even the moment you go to space, you gain not only in wavelength coverage, but also you gain a lot in terms of image quality. Okay, so when you look up at the night sky, you say that the stars are twinkling, and you feel that the twinkling stars are better than when the sky is stationary. But for an astronomer, it is the reverse. We want the sky to be as stable as possible, which would mean that the twinkling would be almost zero. That is why we go to the mountain tops for observations, right? So in the case of, so comparing how the same view looks like from ground and from space, I have here a picture on the right taken by a very large telescope on the ground, okay? And on the left side, on the right side, you have the same telescope, same field observed by the Hubble Space Telescope. So each of these patchy stuff which you see on the left side are resolved as multiple stars by the Hubble Space Telescope. So that is one major advantage of going into space, and one which even implies that we can even get much better results with smaller instruments in space than bigger instruments on the ground. There are advantages and disadvantages on both sides, and one has to, but that's a different topic altogether. Okay, so let's get back to what it means to observe from space. So the Hubble Space Telescope is a kind of, it's a small telescope, almost 2.4 meter diameter mirror, and the mirror will see. So typically, just to give you an idea of scale, this is of the size of a school bus. Okay, it's not a very big telescope. It's a big. It's about a bus-sized telescope, and then you have solar panels on both sides. And let's see what it is made up of and when it was launched. So it was launched by the Discovery Space Shuttle on the 24th of April 1990. Okay, so right from the start, people had decided that they would build it in such a way that they could, send the space shuttle up and replace parts of the telescope as and when needed. Okay, so this telescope was launched by the shuttle Discovery and put into orbit around that time. So within about a day of being launched. Okay, and it is orbiting on a low Earth orbit with a period of about 95 minutes, and altitude is about 550 kilometers. Okay, so this is the reason that the shuttle was able to visit it multiple times. So it is a 2.4 meter mirror. Like I told you that the Mount Abu telescopes are 1.2 meter and 2.5 meter in size. This mirror is 2.4 meters in size, in diameter. Okay, and these are some of the instruments which are available on the telescope. The NICMOS, ACS, wide field cameras, cosmic origin. So multiple kind of, so imaging as well as spectroscopy is possible with this. And let us look at what kind of techniques were used for making the mirror. So you see, this is a person from one of the contractors who made the mirror, and the mirror polishing machine is shown in this. So the mirror is about 2.4 meter in diameter exactly, and almost 30 centimeters width. Okay, which means that if it were to be a solid block of glass, it would be extremely heavy. So normally we don't want a solid block of glass, although in the past people have used that. But in the newer generation telescopes, we want to keep the weight down. And especially if you're sending it up to space, you want to keep it further down. So the weight was reduced enormously by having the mirror made up of support structures which had honeycomb shape. Okay, honeycomb structure, which you can see here. The top is thin enough that you can actually see the structure behind the mirror. So the mirror becomes fully reflective only once the aluminum coating has been applied on the top. And so these are some of the technicians measuring some of the how the surface quality of the mirror looks. This central hole here is the region where you get light coming back into the secondary. So it's a Cassegrain type reflecting telescope. Right? And so when the telescope was first launched, within few weeks it was switched on, and people started, of course, to very excitedly look at the images, and they found that there was a major flaw. Okay, the flaw was like this. They did not get it right, actually. So before, so when they turned it towards a star, they expected a sharp pinpoint like this. Okay, like the image on the right side. But what they found was a star with a lot of aberrations, okay, spherical aberrations. And then they had to, of course, find out why it had happened like that and what to do about it, okay. So the reason why it happened was because there was an error in one of the instruments they were using for testing. Unfortunately, there's only one test that they did with that instrument, and they did not test the mirror again with any other different instrument. So straight away that gave us a lesson for the future that never trust one instrument to test your optics, especially something which is going into space for a important mission. So what they did was like the same thing that we do with the human eye. When the eye cannot see clearly, this vision is blurred, then you put specs. So the same thing was done with this Hubble Space Telescope. In the next mission, which went up to service it, they sent up a set of additional optics, which sat between the telescope and the rest of the instruments, so that the image quality could be improved. Okay, so this is another example where a galaxy was observed. So I should like to point out that, you know, the images, although they were flawed, they were still better than what we could get on Earth. And some of the less demanding work could still be done. And it took 3 years for them to, you know, send up the correcting optics, but they were able to manage that. So how they did was by launching some additional set of optics, which was sent up in 93. So that is about 3 years after the initial launch. And these were some of the other missions which went to this to the Hubble Space Telescope. And the last of them was in 2009. So most of these were for routine maintenance work and for changing of instruments which they felt that could be better replaced with newer generation detectors and optics. Okay, so this was one of the major advantages with the space shuttle and the Hubble combination, that although it was launched with the 1980s or 1970s technology, it was possible to update it right up to 2009, which was when the last mission happened. And in 2009, they installed several new instruments. And for the newer instruments, what they did was that they put in the correcting optics as part of the instrument itself. So the previous correcting instrument, correcting lenses were removed somewhere in between. So these are the kind of things which are possible when you have an observatory in space and you have a way to reach it on a regular basis. On the ground, of course, we routinely remove instruments and change them, and even like you saw, even we recoat the mirrors. All those things are possible on the ground, but not in space. So Hubble is unique in that sense. Okay, none of the telescopes since then have this kind of a feature where we could service them in orbit. Okay, so these are some of the views of Hubble itself. So this is the structure which contains the main optical tube assembly. So the primary mirror is here, over here, and the secondary mirror is here. And you can actually see the different instruments mounted in the large drum-like feature at the end of the telescope, okay, behind the primary mirror. So the wavelength coverage and the kind of instruments are listed in this figure. I will leave it to you to look through them at a later time. I think the slides will be available to you all as needed. So what are the other features available? So this is a telescope which had the idea that there would be actual astronauts who would go and catch it in space, and then make the changes and do the engineering as required. Right? So there were handrails where people could actually hold on to and then make the changes while they did their spacewalks along with the shuttle. Okay, so a lot of optical paths and other things you can see in this. So in fact, I can probably spend entire lectures just on each of these instruments. And, so I urge all of you to, those whoever are interested, to look through some of the links which are listed at the bottom of the slides, and then go through them in more detail to understand what all the functions of these different parts. So this is an example of some of the results from the Hubble Space Telescope. If you see from the ground, you will never see these auroral features which you see here. Which were in Saturn's polar regions, which were shown by Hubble's STIS UV instrument. Okay, and of course, even the resolution that you get from space is unmatched when you look at it from the ground. Similarly, you can see the spots where the comet Levy-9 impact on Jupiter was observed. So this was almost immediately after the Hubble was launched. So this happened sometime in '94. And I also had the opportunity of looking through these, looking at these spots with the telescope that I made myself at Space Application Center as a project student. So it was something very exciting to see such features even with a instrument that you could just barely make with your own hands. Okay, very nice experience. So these are some of the things which Hubble has done. Of course, there are thousands of observations which are available on the web, and one can actually download the data and work on the results by hand. So some of the instruments which are on the Hubble Space Telescope are shown here, and many of these have been removed and replaced by a newer set. And in 2009, a lot of new setup was completed. So this includes the advanced camera for surveys, is a very wide field camera, optimized for very broad imaging, broad field imaging. And then we have the cosmic origin spectrograph, which is exclusively in the ultraviolet domain. Okay. And it looks at point sources and does spectroscopy of these to understand various details of what is happening. And then there are similarly many other imagers and cameras. And then there is something called the fine guidance sensor, which is an important thing in terms of space telescopes and space satellites. So this fine guidance sensor is meant to help stabilize the spacecraft. Okay, so if you look at spacecraft looking at various regions of the cosmos, you'll find that over time there is a jitter in the spacecraft because the spacecraft is moving relative to the Earth. Okay, and in order to make it stable enough, we have something called a fine guidance sensor, which looks at bright stars in the same field of view as seen by the main telescope. And it is able to correct for variations, okay, by providing the feedback to the telescope pointing that it needs to correct in this direction. Okay, so that is the kind of work done by the fine guidance sensor, and it can also be used as a instrument in its own right because it has a very good resolution and this kind of features. There is also the NICMOS instrument on the Hubble, which is as a kind of backup. It is not switched on currently because most of the other instruments are in great use. One of the reasons is that it contains a detector which was launched in the 1990s, and we would like to conserve it and use it in case any of the other instrument fails. So how does the instrument look like relative to a human being? So this is one of the cameras on the Hubble. You can see the people who are working on it in a clean room. So they are all suited up almost. I think you saw similar scenes when people were going into the pandemic affected areas. So here, of course, we want the instrument to be pristinely clean in the UV and optical, because even if it's a small dust speck sitting on the any of the optical surfaces, it will cause a lot of scattering, and that will lead to a lot of issues. Okay, so we try to avoid and minimize that kind of happenings by making sure that everything is pristinely clean. Okay. So let's go through the optical layout for the instrument. So the light comes from the telescope, and there is a pick-off mirror. So this pick-off mirror takes some part of the light coming from the telescope and directs it into the field, into the rest of the optics. So there is a focusing mechanism and a tip tilt mechanism. Various mechanisms are there. And then you have the corrector mirror, which takes care of the optical part here, optical UV part for this detector, which goes into this, and then the infrared part is corrected and sent through the filter wheel and a cold stop mechanism. So all kinds of optics are there in between, which do a lot of jugglery with the light coming in through the telescope. And then it is sent to the corresponding detectors. One is the infrared detector, which should be about beyond 1 micron, and the UV visible, this is a region of about 200 nanometer to about 550 nanometer types. Okay. So those are rough numbers. So coming back to what it looks like. So the Hubble, this is a view of Hubble against the Earth's atmosphere as the last of the shuttles left it. Okay, so you have the communication antenna also sticking out. The door at the top left is a kind of sun shield so that the sun doesn't enter, sunlight doesn't enter into the main heart of the instrument. So some of the challenges in this kind of an instrument are because it's at low Earth orbit, so it would have very rapid a change of day and night cycles. Okay, you saw that it was having an orbit of 95 minutes. So that would mean that it would go through extremely strong thermal cycling as it orbited. So in order to prevent that damaging rest of the instruments and the optics, there were several layers of insulating material, and that is part of this telescope, and that's also the reason why this telescope was weighing almost 11 tons at the time of launch. Okay, it's one of the heaviest telescopes in orbit. In fact, some of the newer ones like the JWST are a fraction of the weight, and the idea how they did that was by coming up with really innovative ideas in terms of design, both of the spacecraft as well as the optics, and as a combination. So next I will talk briefly about two infrared space observatories, because I'm just, I think I should speed up. So this infrared space observatory on the left side is shown in a test chamber in the European Space Agency buildings, with some people standing around looking at the tests being carried out. They are just to show the scale of the instrument. At the same time, on the right side, we have the Spitzer Space Observatory. The reason I'm showing you these two instruments side by side, the observatory side by side, is that you can see that they are rather similar in features. You have the solar panels on one side, which protect the rest of the telescope from the heat of the sun. So the solar panels are always pointing towards the sun, and the rest of the observatory points towards the target of interest. Okay. So there are strong constraints on which directions you can point and actually observe. The other reason is that these were just about a decade apart in terms of their design and their capabilities, and we'll see quickly how it makes an impact. Okay. So the Infrared Space Observatory had again a relatively, it had a very highly elliptical orbit and a period of 24 hours. Okay. The telescope had a mirror of 60 centimeter diameter, and 4 different instruments were installed at the time of launch, and of course all 4 remained available right up to the end. With the Spitzer Space Observatory, the orbit was quite different from Earth-centered. In fact, it was heliocentric and Earth trailing. So what it meant is that with time, the telescope was drifting away from the Earth. And both of these telescopes were launched about a decade apart, about 7-8 years apart. And then the technology that was available was quite different, especially in terms of the detectors. And you will see that, for example, in this here is a mosaic of images taken of the galactic center using the Infrared Space Observatory, okay, and with the ISOCAM instrument. And I was involved in building this one. And you can see that this is the full field of the Infrared Space Observatory. The central part was not observed because it was too bright to be observed by our detectors. They would have saturated and burnt out, and we would not have been able to do anything further. But the instrument which came later on, the Spitzer, had a different set of detectors, and they were actually able to cover the entire galactic center region. And I think many of you might have seen this spectacular view of the central regions of the Milky Way. So these are views taken with wavelengths around 3 to 8 microns. Okay, so these are really in the near to mid infrared, what we call, and the observatory requires to be cooled down to liquid helium temperatures to actually observe these regions. The next observatory I will talk about very quickly is the Herschel Space Observatory. And this observatory again is a observatory which has a 3.5 meter telescope, and it initially had a mission duration of 3 years planned, and then eventually it was found that it lasted for 4 years and plus. The telescope weight you see is so small. I mean, the entire weight of the telescope, including the propellant and coolant and everything, was just 3.4 tons. Now, when you look at the details, it is orbiting a point known as the L2 point, which is, as you might have heard yesterday or today, is a point which is balancing the sun and earth gravity. And the advantage in this location is that both the sun and the earth, and of course the moon, are in the same direction as seen from the observatory. Okay, so then by avoiding one of these objects, you are avoiding all the three, and the rest of the sky is available for observations. Okay. The mirror here is a 3.5 meter diameter mirror and a very high curvature. And you can see that it was actually designed for wavelength from 55 to 672 micron. Okay, so at this temperature, you are looking at objects which are extremely cold. Okay, typically they are molecular clouds. So using this instruments and different techniques, we have been able to look at objects which are really very close to the background temperature of the universe. Okay, so for example, here operating temperature is less than 2 degree Kelvin. This was achieved using liquid helium, which was in the drum placed below the telescope here. And in fact, it had also many other cooling mechanisms, which I do not have time to go into right now. Let's see. And then, so these three specific instruments had completely different methods of working. And they had photodetectors as well as heterodyne instruments. So they are different techniques in detecting light at longer wavelengths. Okay, it's going into the sub-millimeter. And this sun shield, which you see this this golden structure with the blue thing at on the side. So this part is your solar array, and it has two functions. One is to charge the power banks of the telescope, and the other is to protect it from the heating radiation coming from the sun. Now, if you see in newer observatory like the James Webb, I talked about it momently, similar concepts have been used in all spacecraft since then, which were orbiting the L2 point of the Sun-Earth system. So what shall we do next? Let us go and look at the James Webb Space Telescope. I think many of you might have heard about this exciting new machine that we have for astronomy. It's a spectacular success of technology of the latest type, wherein the observatory was launched in a packed condition, and it unpacked and unfurled step by step. As seen in space. Okay, so this is an artist impression of how it appears in space, and actually it was launched in a completely packed position. In fact, even these mirrors were folded backward, and the secondary mirror at the top was also folded and stored away. So a lot of work was done. So it was launched on the 25th of December last year. And it is expected to have a 20-year lifetime. Let's see how it goes ahead. So the telescope has 18 hexagonal mirrors arranged in a specific pattern, and then the overall effective diameter is 6.5 meters. So it's the largest telescope flown into space so far, and the wavelength coverage is somewhere in the visible to mid-infrared, so from 0.6 micron to 28.3 micron. The human eye is capable of seeing wavelengths from, let's say, 0.4 to 0.7 microns. So there is a small overlap with the visible, and mostly it is confined to the infrared. So there are several instruments on board this telescope. MARI, NIRCam, NIRSPEC. So most of these are infrared instruments. And again, here this telescope has to be cooled down to really close to the background, universal background of 2 degrees. Okay. So in this particular telescope, they have used passive cooling mechanisms. And these layers of film, which you see here at the base of the telescope, these are pointing towards the sun, and which is the only source of heating radiation coming to the observatory. So by blocking the sun layers, and then it's basically only the radiation which needs to be blocked. So by having multiple layers of these reflecting material, you are actually blocking the radiation quite substantially by the time the last layer is reached. So this allows you to really, cool down the telescope and keep it at a stable temperature for a very long period of time, so that the operational lifetime of the observatory is defined mostly by the propellants that you have on board for pointing, rather than the coolant that you use for cooling the mirror and the instruments. Let's see how this has been in service. So when it was launched with the mirrors in a stored condition. They were all unpacked and unfurled. And then here you can see a sequence of works that were done, wherein we were able to actually see the mirror after it had been unfurled by looking at it using a different instrument, which was part of one of the NIRCam instruments on board the telescope. So the 18 segments can be seen here on the left top panel. And then the images from each of these 18 mirrors, before they were really aligned and put into place, are shown in different panels here. And then as you see towards the bottom, towards the the second, the biggest, with the bright star and the spikes at the center, that's after they had completed the final alignment. And it's a star with a very specific name, a fairly bright one. That is why you see all these spikes. But then of more interest to astronomers are all the faint specks of galaxies seen behind this star. From the ground, we would never be able to see these objects because they would be lost in the glare of the bright star seen at the center. So that brings us, I think, almost to the end of this work that has been happening in international situation. But I have one more instrument I would like to talk about before we, which is the Gaia. The Gaia Space Observatory is again an observatory at the L2 point. So at the L2 point is a very favorite location for astronomers and space scientists to put their telescopes to observe the universe. If there are questions, we can discuss how we have so many of them at the same point in space. Okay. So this specific observatory is a very special observatory. It has 2 telescopes on board, and using them, it is able to find the distance to the background stars. So the main purpose of this observatory, I think speed up a little bit here, is to find the proper motion and the parallactic distance for over 1 billion stars with an accuracy of 20 microarcseconds. So there used to be a comparison somewhere which said like you are then positioning the you are getting an accurate position of a human hair at a distance of 1,000 kilometers. So it's something like that, the kind of accuracy that they are trying to achieve with this. Now, 1 billion stars might appear like a big number, but it is just 1/100th of the population of the Milky Way. But the results coming from this observatory are spectacular, and we have learned a lot about the Milky Way from here. So how does this work? So it has 2 mirrors. You can see them as M1 and M2 here. And then it gets reflected and comes down to the focal plane where the images are merged side by side. And by looking at two different parts of the sky, we are comparing the positions of the stars and retrieving the information about how they have moved with time. And apart from that, a lot of other instruments are there which allow for spectroscopy as well as for various other phenomena to be understood. Okay, so this was an observatory which was launched by the European Space Agency, and they could also like a lot of data is coming through now, and we are expecting another release of data in the next few months, and that will revolutionize our understanding of the Milky Way. That is what is expected. Now, when this was launched, also there was again some issues were discovered, that there was a stray light issue. Okay, so light diffracted from edges of the sun shield entered the telescope apertures, and because they entered the telescope aperture, they were getting reflected onto the focal plane. So it was found that these were basically because of fibers in the sun shield protruding beyond the edge of the shield. Okay, so which means that eventually you have some amount of background light which is contributing to the background of the telescope. Okay, so this would mean that the faintest of the stars which Gaia was looking at would have issues with their positional accuracy. But it's not a major issue. We still have more than 99% of the stars still observable with it, and results are really expected to be quite impressive. This has a lot of, in fact, I can spend probably a couple of hours talking about this observatory and the results, as well as the optics that have gone into it. It's quite spectacular. Now, what people have done is also, not apart from space, one can also do some things from near space. So, for example, we can use the Sophia Observatory, which is taken from, which is a NASA and a German collaboration. They have put a 2.5 meter telescope inside a Boeing 747 aeroplane. And after it reaches its height where it is cruising, they open up the aperture here and then have the telescope look at the night sky. And the advantage of putting it up on this kind of an observatory is that you get access to infrared bands which are not reaching the ground. And you can also change the instruments the way you used to do on Hubble, but at a fraction of the cost, because flights of the observatory are much cheaper than rocket launch, right? So this is all that I want to talk about in the international scenario. Let us look at some of the Indian scenario now. So of course, I think everybody knows about the AstroSat Indian Space Observatory. I will talk about just one of the instruments on this observatory, which is called the Ultraviolet Imaging Telescope. It is made up of two identical telescopes of 37.5 centimeter. And one of them looks at the near UV, which is from 200 to 300 nanometer, and the other looks from visible, that is 320 to 550 nanometer. The third telescope, the second telescope, looks at really the far ultraviolet, which is from 130 to 180 nanometer. And it's not that this is the first ultraviolet telescope in space. There have been instruments in space earlier. For example, the Galax. Okay, now the Galax had a spatial resolution of 5 arcseconds, whereas the spatial resolution of UVIT is 1.8 arcsecond. Okay, so this resolution is decided by the size of the primary mirror, okay, and the detector combination. Now look at how we have gained in terms of spatial resolution. On the left here is an image of a part of the Andromeda galaxy observed by this group of foreign investigators. I really like this work because it's something done by foreign members, but with an Indian observatory. Many times we have Indians working with foreign equipment, but this is a nice example of outsiders using our instrument and actually observing and getting results. It's just that I thought this is a good instrument to good field to show. There are, of course, hundreds of such examples by Indian astronomers looking at various objects in our galaxy using this telescope. So this is the UVIT image of the same part. On the left side is with Galax and the right side is with UVIT. Okay. So what are we going to do after this? This is still in our service, of course, but astronomers are never at rest, and we are now proposing to build something, or actually insisting to build something called INSIST. So what is this? This is science. This is an Indian spectroscopic and imaging space telescope. So the short form is INSIST. And we plan to do a lot of science with it, covering from solar system bodies to cosmology. Okay. And the main comparison is with UVIT, because we are planning to cover the same region. And here you have an idea of some comparison of the kind of features that we shall have. The central column is the currently available UVIT instrument. And on the right side, we have the INSIST facilities, parameters. So the INSIST will use a 1 meter telescope. It will have a spatial resolution of 0.2 arcsecond. So you see it will be even 6 times better than the UVIT, and almost 25 times better than Galax. The field of view is a massive 30 arc-minute field, and the wavelength coverage is from 150 to 550 nanometers. And we shall have photometry, spectroscopy of various types, as well as something called precision photometry. So these would be used especially for exoplanet observations. There are various wave bands, and then talk about the different kinds of sensitivities we shall be reaching. These are all slides and material taken from a recent presentation which the INSIST science team, of which I am a part, we made at the recent Astronomical Society of India meeting in March. So it's about last week sometime. Another example slide I would like to share with you is the field of view of the instrument and what different detectors and optical fields we shall have. So these are all going to have multiple mirrors to reflect the light finally into various filter and filter combinations, which would allow for simultaneous imaging in UV and optical, okay, in various bands, and each of them would have imaging and or spectroscopic capabilities, okay, based on the kind of optics that the light passes through. On the right side, the red rectangle square shows the field of view of the observatory overlaid on an image of the Andromeda galaxy, and the green and the blue rectangles show the corresponding fields of the other instruments on board the telescope. Okay. Finally, let me show you one image of a simulation of what we expect to be able to achieve with INSIST as compared to UVIT. I think at this point, the spectroscopy is also shown in various modes. I will, I think, stop here and take questions. Of course, I have not been able to take a lot of, I have not been able to cover a lot of other missions and other programs which people have proposed. And of course, there are a lot of other things like UV polarimetry, and then a near-infrared version of Gaia. Gaia is, of course, working only in the optical. So there have been talks about building a near-infrared version. There are various points why we would want to do that. Polarization has not been used much, so that's of interest as well. So I'll just stop at this point, and if you have any questions which you would like to ask me, you're always welcome to write to me at the email ID specified on screen. Thank you.
Thank you very much, sir, for such a beautiful lecture. I think this was one of the unique talk we had as a part of this awareness webinar series related with astronomy and astrophysics. So forum is now open for questions. participants can directly ask questions to sir. Okay, sir. May I ask a question?
Yeah, please.
Yeah. Sir, you spoke about the Sophia Observatory, which does the IR imaging. So if the plane is having some turbulence, so how that is taken care of while focusing on very narrow part of the sky?
Right, right. That's a very good question. So actually, this plane reaches altitudes which are not normally used for commercial flights. Okay, so we are at an altitude where the atmosphere is really very low amount, and so which means that there is no major turbulence, and this allows for the pointing and imaging and spectroscopy or whatever you would like of a very small part of the sky. We are well above the Earth's atmosphere, almost into the stratosphere.
Okay, thank you. Sir, recently even I saw that Ares even launched a completely new kind of telescope, a liquid-based telescope. So if you could also share regarding this telescope.
Right. So I have seen the structure which they were building when they were building it. So it's a liquid mirror telescope. Okay. So what they do is they pour mirror. So for light to be reflected, you need the surface to be of a parabolic shape, and you need the reflectivity to be maintained. So it's difficult to do this with the conventional glass and with large surfaces. So in order to reach those large surfaces, what they have done is to use a kind of rough surface and then overlay it with liquid mirror, mercury. And when the mirror is rotated on its axis, so at that point of time, the mercury spreads over the entire surface and makes a full reflecting mirror. And this allows for achieving large surface area mirrors, which allow for more light collection at a fraction of the cost of a full telescope of that size. Okay. The only disadvantage of this is that you have to look at only the part which is vertically above the observatory.
Right.
So you cannot point in all directions. So you can observe a narrow patch all around the sky, which is accessible to the observatory. But there are other major advantages which offset for that issue.
Right.
It would be the India's largest telescope, actually. That's right. It's just next door to the 3.6 meter at Devasthal.
Participants can post their questions in the chat box, or even they can directly ask.
You can ask question in your regional language also. You can ask in Kannada, your professor can translate. Don't feel shy.
Yeah, I can understand Kannada as well.
See, he can also understand and reply you in Kannada. So you can.
I'm not so sure, but I can try.
But most of the students are from Karnataka. 80% of them.
Okay.
And then if you are from Trivandrum, Chennai, and northern part of it.
Right.
Because the management of this college, Jebin College, has taken a lot of interest in organizing this particular activity.
Yeah, it's a really nice initiative.
Mostly students are from BSc, MSc, and research scholars.
Right.
But they are not asking question. Anyway, you can ask later on. Also, you can note down his email ID and ask directly.
Yeah, that's right.
Okay. Sir, one question I will ask, not directly related with the field. This is about that your first telescope which you have shown. It was installed sometime in late 80s. Okay, how it is performing now? Any major mechanical problem or maintenance kind of problem?
Okay, so you're talking about this one, right?
Yeah.
So this one was built by ISRO, actually by Shar Center. And then our engineers have been updating the electronics all through.
Okay.
Mechanical system is extremely robust. And the electronics has been completely replaced, and so far we don't have any major issues with it. Okay,
and what about the shutters now which you open in the night time? Any sliding problem in those?
So there have been issues with that, but then it requires routine maintenance and refurbishment. So some discussion.
So this work was done by that Chennai-based company, Prabhakar Products.
Yeah, right. So
they still ask me many times how it is performing. Do you have any idea? I said no. I will ask and let you know.
Yeah, probably I'll talk to you sometime. I think there have been some discussion about refurbishing some of the things. So
okay.
We'll see. It's to be done.
Okay. Chintamani, next talk will be at 2 o'clock.
Right.
And 1:30 we will break. So we have another 25 minutes or so. If you allow me, I can take around 15 minutes or so out of this. Just general discussion with the participants.
Yes, sir.
No problem. No? Sir, yes, thank you.
Go ahead.
Sharing that.
Kiran for accepting our offer.
Okay, thank you so much for
your valuable time. And our purpose is a lot of retired engineers from SAC. They have joined my team and helping me in reaching to the young students of the country, trying to have more and more awareness programs just to educate them about the space related topics.
Right.
And hope we'll get your support in future also.
Sure. Yeah.
Thank you, sir. Thank you once again.
Thank you. Bye-bye.
Bye. Yeah, can you see the screen?
Yes, sir.
Yeah. Okay, so I'll take some time. Just would like to brief all the participants that our first satellite of ISRO of India, it was launched on 19th of April 1975, and that time we say India entered into the space age. So we are having 47th anniversary of Aryabhatta launch, and this particular satellite, you can see the image, and it was launched by Russia. And Russia used to help us a lot earlier days because we were not having the capability of our rocket to launch it. But we made this satellite in Bangalore, and there was a team which was involved in making this particular spacecraft. It was in Pune, Bangalore. So we thought of having a program on this 47th anniversary. So we decided to have a series of lectures on artificial satellite from 19th April to 21. It is 3 days and maybe 11 to 12 talks and 4 talks per day. And mostly we are thinking to have these talks in afternoon so that the students community, they can attend their classes in the morning, and after that they can attend these talks related with artificial satellites. So that is why we have kept it is for 3 days. And there are most of the speakers are from ISRO and 1 or 2 from the academic field who are helping us in organizing this. And Dr. R.K. Rajangam, who was the project director of INSET 3A, 3C, he has kindly agreed to be the chief guest for this, and he will deliver a talk on the Aryabhatta project. You know, earlier we were having very limited facility and everything was new to us. We were not having experience of the design, fabrication and other things. So how this project was conceived and we realized, and finally it was launched. And later on, as on today, India has launched so many satellites. So there are many students, even academic faculty members, institutes, they are thinking of sending satellites into space, and ISRO is helping all of them. So we call these small satellites as student satellites, where students and the faculty they are supposed to make these small satellites, and ISRO helps them in designing, fabrication and launch. Okay, so far I think around 10 or 12 student satellites have been launched by ISRO, and by Anna University. They have made, there are many universities in the country who have made this, and this year they are planning to make 75 satellites launch because of our 75th year of independence, and many institutions they are thinking so to make, and ISRO will launch these 75 satellites in one go. So basically a number of companies, small companies, they want to enter into the business of satellite design and fabrication all over the country. Many institutes they want to do research in the field of satellite design, and like other countries, ESA and NASA, academic institutes are supposed to deliver the total satellites to the country. So on that concept we are going, thinking all that, we thought, okay, let us have a awareness program on this. So around 11 talks we have planned, and they will cover about the basics of satellite system, artificial satellites, its manufacturing, power system, materials, then how to test this satellite in various chambers before the launch, and then integration related problem. Then there is a society, Planet Aerospace in Bangalore, and they will also make a presentation how they are organizing their activities in the field of spacecraft fabrication, like that. So this copy of this brochure, information brochure, I'll send you by email today or tomorrow, and those who are interested, they can register for this particular activity, and those who are from some industry and wants to do enter into this particular field, they can also join this program. So we will not go in very deep technical things in this particular program, and just because we want to create awareness. And there are many institutions who are helping us. Space Technology Cell, which has been established at IIT Roorkee in 2000, I think 19, and it was established by ISRO. It is a joint cell at IIT Roorkee, and they are co-sponsor of this program. Then Untitled Technology, it is a very big company now in India who are into the satellite design and fabrication. There are a lot of components they are making, and they have got a unit at Hyderabad as well as in Bangalore. So another company at PMG Engineering who are good in fabrication, and this young boy who is running this company, they are also one of the co-sponsors. They have joined hands, and there are a number of knowledge partners who are helping in organizing and finalizing the concept for this program. That is again Space Geeks Mumbai, Planet Aerospace, then Safety and Quality Forum, Institution of Engineers in New Delhi, then Society for Small Satellite Systems, it is a registered society at Bangalore, then Engineering Technologies Bangalore, and many other institutions like Institution of Engineers, IEEE Gujarat section, and IIT Roorkee Alumni Association, then Broadcast Engineer Society, Ahmedabad chapter. MyCope is a private company who is working in the field of 3D printing, and they are also joining hands. They are our knowledge partners and supporters for this program. Okay, and other than this, I'll take just 5 more minutes. I think Dr. Alok Mathur is here, who retired from ISRO Ahmedabad. He was head of the division, and yesterday he has delivered a talk. related with the satellite meteorology or weather applications. I think all of you must have attended. He is here with us. A few months back, he has written a book on applications of remote sensing for the common man. This book is written right now in English, and it contains information related with the various applications in a very simple language, so that a common person can read this book and try to understand what are the various applications. So I will request Alok Mathur to brief you about this book, and we are looking for good technical persons who can help us in translating this particular book into various Indian languages, so that we can reach the root level people like Karnataka, Andhra, even Bengal, so that the students who are studying in their regional languages, they can also understand what is there in this particular book. So I will share the book cover, and Alok Mathur will make a presentation. Another information is this Ananta Technology Hyderabad. They are sponsoring copy of this particular book in PDF form. On behalf of this company, we will be sending all of you, all those who have registered for this current webinar series, a PDF copy of this book free of charge. So that will be complimentary by Ananda Technology Hyderabad, which we will send tonight or tomorrow. So Alok Mathur, if you are here, you can just make a small presentation about this book. I will share the top cover of that.
Yes.
Yeah, I'll see. One minute. Yeah, can you see this cover?
Yes, sir.
Yeah. So Alok, you are requested to explain about this book, so that all our participants are get benefit.
Okay, thank you, Dr. A.C. Mathur. Actually, whatever he has described earlier, this book has been written in order to popularize satellite remote sensing. And so, the very common man applications are described in a very lucid manner here, without using much of a technical jargons of satellite remote sensing. If I can share the screen, I can go to the some part of its application, which may be of interest to all of you, because some of the applications I have covered is very interesting, in the sense that yesterday I told you something about the weather prediction, how satellite remote sensing is helping in weather prediction, in water resource monitoring, in ocean state forecasting, in study of glaciers and snow monitoring, earth observation in day as well as night, then agricultural practices, forest cover, then disaster assessment, and renewable energy by using wind as well as the wave. Then two more applications are for rural and urban development, some innovative applications. Now, innovative applications I wanted to show, but actually these I'm not able to open the PDF, but I will tell you the innovative observations. One of the observation is how these Earth observations can be utilized to know who is the defaulter in income tax. So you may be surprised to know that many users or the farmers, they go for tax exemption because agricultural income in India is exempted from income tax. But in some of the cases, these farms or the lands which are not exactly utilized by agricultural farming, they claim that it is agricultural land, and so they want to they want to have exemption of tax for that particular land income. So some of the queries by income tax department has been sent to us in Space Application Center, and we used to verify those claims. And the idea is that you go for that particular year's land classification or the usage of that land through satellite images. Now, through satellite image, we can know that whether that particular land was having a crop standing over there in those years or those days where it has when it was claimed to be. But actually, so we used to verify whether it is a farm there or it is not land there, or it is something else which is being built or which is being developed there, like a marriage hall or something like another source of income. So we used to verify those claims by the farmers and then tell income tax authorities that okay, this is the actual usage of the particular land, and you can accordingly decide whether to tax it or not. So this was a very innovative application which we found it should be known to the student class to have a you can say a good appreciation of the remote sensing, satellite remote sensing capabilities. Okay, so then yes, there are so many speakers which talked about the forest fire monitoring. Of course, this is also a very unique application of satellite remote sensing, because you know that forest fires are vast in nature, and several hundreds of kilometers of area. You might have heard in California, the whole of village was burning like a furnace. So how to monitor its progress, how to monitor its intensity variation or the trend from which place to which place it is moving. So only through satellites we can see that the area is being engulfed in a north side or south side or whichever side, because the authorities can take care the precautionary measures to control the fire or to evacuate people from there. So these are some of the things which I wrote in this book. Another interesting part is again a kind of theft in the oceans. Now in oceans, you know that fisheries is a big economic resource in the oceans, and fishermen sometimes are not allowed to fish during the spawning period of fishes. So that time fisheries is banned over certain regions where the natural occurrence or the you can say the breeding of fishes are allowed, and so the fishermen are not allowed to fish in those waters during spawning period. But even then, because it is their livelihood. So they used to go there in spite of the ban, and they do it in the night time, because earlier we used to detect this kind of theft in the daytime, and in daytime visible imageries of satellites, they tell us with the satellite images, they tell us that okay, these are areas where some unscrupulous boats are having um, uh, so Coast Guard people used to catch hold of them and take appropriate action. But fishermen again were smart enough to circumvent that part, and they used to do it in the night time, so that the visible imageries of satellites are not available in night time, and they used to do all these things in the night time. Now in night time, what they do, they used to light very high intensity bulbs inside the water, and the attraction of very high light a pool of the source, and they used to fish very handsomely during night time using this kind of light source. So that part was also taken care by again Coast Guard and satellite people. We were helping them to know that in night time who is fishing, and because in infrared images one can know that whereas the high temperature areas, you can get a very good picture. So I have shown this picture in the book also, that these are the places where very high intensity bulbs are being lighted to catch the pool of fishes, and by satellite images we can catch hold of those fishermen who are fishing in the night using this kind of activity. So these are some of the things which I have described in this book in order to attract students to know that there are some very innovative ways of utilizing the satellite images. So basically then there is one more application of using it to track the extinct species of birds. So if you can know the track of a bird. Now, suppose you catch hold of a bird and tag it with a, we call it as a radio frequency tag, so that it transmits a signal to the satellite, and that particular bird is being tracked through that signal, and wherever it goes, it emits a signal. So we know wherever it has reached and wherever it has gone. So migratory birds are can be studied through this technique, and such kind of you can say the applications are also being utilized in the area. Then there are so many. Oh, okay, one more thing is oil spill detection. So the merchant ships often disposed of their refined petroleum products from the ship. Now, actually, in ships, they used to carry some redundant material from the refineries, which oil is like a trash for them. Now, in order to get it away in the land area or the refinery, it is very costly. So the very cheap way of disposing it off is by taking it into ships And wherever they find that nobody is observing, they used to just spill it over the oceans, and it goes down, and nobody knows who has done this culprit work. So that was the reason when satellite remote sensing came into help. And in night time, these activities were observed through satellite images. Now, you know that whenever oil is spilled over oceans, its optical characteristics as well as its thermal characteristics are changed. Now, through satellite images, we can know that this is the area where the earlier water was having a different temperature than the temperature which is being shown after spilling oil over it. So that was the main, you can say, characteristic of the thermal and optical properties of ocean water, which helps us in catching hold of those culprits who are spilling oil or the trash oil from their refineries into the ocean. So that is also a very innovative application of satellite remote sensing. Now, okay, one more thing which I wanted to tell you is the alert for malaria. So in medical science also, the satellite remote sensing is being utilized. And as you know that the mosquitoes, they grow very fast in particular temperature and humidity. So at a particular temperature and humidity, the whatever medical history tells that in a particular location, if the temperature is in the range of some particular temperature range, and humidity is suppose 40 to 50%, then the mosquito breeding is very fast. So if this happens historically at a particular place, we used to give a warning or alert to the local authorities so that they take care or they take the precautionary measures to control the malaria. One more thing which I would like to tell, which is written in this book, is the encroachment in the Sanjay Gandhi National Park, Mumbai. See, you may be knowing that Sanjay Gandhi National Park, Mumbai, was declared as a national archive, and so it was under the government of India to take care of its species and all other its flora and fauna. But slowly, by the side of Sanjay Gandhi National Park, there were some tribal areas which were growing in its inhabitants. So they used to reside in the Sanjay Gandhi National Park, and they used to encroach this part, and they encroached several meters inside the park, and that was like illegal. So that was this case was put in a court, and court directed ISRO to tell them that what is the actual situation. So what we did was that before the Sanjay Gandhi National Park being in a Government of India control, and after this control, how these images look like. And that clearly showed that some of the region in the boundary area was encroached by the tribal area and other Juggi Jhopdi colonies, and that was really an encroachment. So that also helped Government of India to remove that encroachment, and so that park was you can say flora and fauna was saved using satellite remote sensing. So that was one of the interesting part of this book, which I have covered in order to attract students to know that remote sensing not only monitors and observes the natural resources of nation, it also has a vigilance kind of activity, or you can say role in the national development. Another part, okay, I will also tell one more application, which is for the monuments. Now, you know that many monuments in India, historical monuments, they are having lots of population near the monument. Although those are like some shopping malls, or some utilities, or some public places, but some of them are illegal. So what Government of India told us, ISRO helped Government of India in monitoring and redesigning those areas, was that how that particular historical place is important to us. So the through satellite images, we used to encircle a crucial area around that particular monument, and then tell the authorities that okay, this is the very crucial area, so no construction should come up within this area, and outside that area you can construct whatever utilities or shopping malls or some public utilities you can construct. So almost all the historical places we have done that using satellite images, and this archaeological department has taken a very serious note of it, and they have removed all the unauthorized structures around that.
I think, Alok, you have explained a lot
Yes,
of things to them. These students also should get interest in reading the book and find out what are the other applications.
I think
Otherwise
yes,
they
they
will not
will.
read the book.
Yes,
Yeah.
they should go into the details by reading the
Yes.
book. And as Dr. A.C. Mathur has told, that this book will be provided to them in a very short time. PDF is also there, and you can as well print it through your local resources if you want to have a physical feeling of it. I think that should give a good attraction to have that book. Thank you.
Thank you. Yes, Chintamani, you can proceed further. Yeah, this is the book. Yes. Yeah, you can, I think, now conclude now. We can meet around 2:10 or so. The next speaker will join at 2:10.
Alok Mathur sir for to get the copies of the book and really help in the space Indian Space Research Organization. That we conclude this session, and we'll have a lunch break for half an hour, and then we'll be joining at 2 o'clock with the next session.
So, Chintamani,
Hello,
have you joined?
Yes, hello,
yes,
Mataji.
Hello, how are you?
Yeah, fine. Hello.
You are joined. Good.
Joined.
Nice to see you.
Yeah, same here.
So, Chintamani, speaker is ready, and
Okay.
I think you can start.
Okay. Is Professor Santosh there?
Yes, sir.
Okay. Just give me a moment.
Am I audible now?
Yes, sir.
Okay. Good afternoon, everyone. So we are back to our awareness webinar series on opportunities for science students in space sciences. And it's a great pleasure to have Professor Sumanta Sarkil from IIT Roorkee, who is going to talk about the opportunities in space sciences for students. And may I request Professor Gorfade from Pesi Jebin Science College to introduce our speaker for the session.
Thank you, Chintamani, sir. Very warm good afternoon, resource person, dear participants, and all the delegates. I'm very glad to introduce a resource person, Dr. Sumanta Sarkil, Associate Professor, Department of Physics, Indian Institute of Technology, Roorkee, Uttarakhand, India. And the Sumant sir completed his PhD in the year 2011 from the Physics Research Laboratory, Ahmedabad. And as per the academic qualification is concerned, sir has passed all the examination, just examination, that is a joint entrance screening test examination with the Indian rank 148 two times, 2005 and 2006. And also after completing his master's, sir has cracked the CSIR net JRF immediately, and also sir has qualified with the GATE examination, graduate aptitude technical examination. And as per the research experience is concerned, sir is having a lot of research experience. Sir has served postdoctoral fellow at the Space and Astronomy Astrophysics Atmospheric Science Division in the Physics Research Laboratory, Ahmedabad. And also sir has worked as a postdoctoral fellow at Pennsylvania State University, USA, United States of America. And there only sir has served as a research associate. And also sir has served as a postdoctoral fellow in the Korea Polar Research Institute, South Korea. And sir is also a visiting scientist at Atmospheric Physics Laboratory in Germany. And as per the research publication is concerned, sir is actively reviewing the 8 peer-reviewed journals. And also sir has published 28 research articles in international and national reputed journals. And as per the teaching experience is concerned, sir is having more than 10 years of teaching experience in the India's reputed institution like Indian Institute of Technology at the different levels like undergraduate and postgraduate levels. And as per the administration experience is concerned, sir is worked as a office in charge for Atmospheric Physics Laboratory in the IIT. And sir has supervised the 4 doctoral theses, and in that 3 are ongoing and 1 is already awarded. And as per the research project is concerned, sir is undertaking the 4 different research projects under the title of Department of Science and Technology, Disha H and Disha L. And sir is also having the lot of invited talks and special lecture throughout the India, and that number are 8. And with this, the vast research experience and teaching experience and well qualified, I introduce before you Dr. Sumant Sarkil. Sir, welcome you, sir. And right now the seminar is with you, sir.
Okay, thank you very much. So, and I thank Dr. Mathur for inviting me to give this seminar. So, since this is for UG and PG students, primarily for UG and PG students, so I have made the talk in such a way. So, I hope that the students will have glimpse of my talk, and probably they can be interested in the space sciences. Okay? So primarily today I'll talk about the research activities which we are carrying out at IIT Roorkee, at Department of Physics, IIT Roorkee. But before that, let me introduce this. What do you mean by space sciences? Because I'm sure that many of the students may not be knowing exactly what you mean by space sciences. So space sciences is nothing but what we call it. We talk about like atmosphere, the near Earth space, and so on. And then, of course, interplanetary space, okay, where we call it the beyond Earth atmosphere, things are there, right? So we are interested in near Earth space, okay? Atmosphere and space, whatever we call it. So the atmosphere in Earth atmosphere is basically divided into several layers, okay? So based on their properties. So one property is the temperature, and based on the temperature, this layers, the Earth atmosphere can be divided into several layers, as I talked about. And these layers are like troposphere, stratosphere, mesosphere, thermosphere, and so on. Then there are other layers, which is called ionosphere. So ionosphere is a region where we have a lot of plasma. Plasma means basically charged particles, ions and electrons. So these are also have certain properties, and based on their plasma properties, this ionosphere can also be divided into several other layers. Okay? So you can see that there are a lot of layers in the atmosphere. Okay? So for example, in the troposphere, the temperature decreases with altitude. Okay? So you see, this is the vertical axis is altitude. Okay? So because the vertical axis is altitude, because we have altitude is always like vertically up, right? As you know. So it is really easy to comprehend that if you put it in a vertical axis, y-axis, so we have a better visual field. I mean, that is why we normally keep it in the altitude is a vertical axis, okay? And this x-axis is the temperature. Okay? So you'll see in temperature in Kelvin. Okay? So you see that temperature on the Earth's surface is like something like 300 Kelvin if we just average temperature, we call it. So now, if you go up, the temperature decreases, as you know, and I mean, if you go to a hill stations, right, for example, so you'll feel a little bit cooler. So that is why because the reason is the temperature decreases with altitude. Okay? So I'm not going into detail why there is a temperature decrease with altitude, because there is less time, and I cannot explain in this this lecture. Okay? So now, for the time being, you just trust me that temperature decreases with altitude, and after some time, the temperature actually increases with altitude. It's very strange. So this is because of ozone molecules, they absorb solar radiations and they heat up. So that is why there is a ozone molecules here in the stratosphere, and then the temperature actually try to increase. And there are other time at what happens beyond stratosphere, temperature again decreases. So that is because of some molecules and atoms, they actually radiate, and it's called radiative cooling mechanism. And that is the reason temperature decreases. And beyond mesosphere, temperature again try to increase, okay, in the place called thermosphere. And after some time, it try to be constant with altitude, because it neither decreases nor increases. Okay? So you can get to know about this altitude sense. So for example, you see, this is the Mount Everest, you can call it, almost 8 kilometers or so. And this is where the International Space Stations are there, 300, 400 kilometers. So all this aircraft, we fly within this tropospheric region mostly. Right. There are, of course, aircraft that fly in the stratosphere region, but we're not going into the detail of it. So mostly the military aircraft, as you probably know. And this, you see, this is this space shuttle used to be there. So this is the altitude where we are talking about, where there's a lot of plasma, this charged particles. So, and this is not a hostile, it is not a place where you can live just like that. So this is particularly designed for that region, as you know, International Space Stations. So this is the place where we actually live. Beyond that, the temperature and the pressure may not be suitable for our living. And there are places where all sort of like radiation is getting absorbed. So mostly all this high energy radiations, they are getting absorbed within this region. Right? And some visible infrared, these are coming up to the Earth's surface. Right? So that is what that we divide the Earth atmosphere based on temperature. So now we can divide the atmosphere again based on plasma parameters, as I told before. You see, so this is the ionosphere we are talking about. So based on plasma, because Earth has plasma, Earth atmosphere has got plasma. The reason is the radiations, the solar radiations, the X-ray, extreme ultraviolet, sometimes gamma ray as well, a little bit of gamma rays. What happens? They try to dissociate and ionize atmospheric molecules and atoms. Right? And that's why we call it plasma. So it becomes ionized now. Right? But only like less than 1% of the whole atmosphere getting ionized. So we have ionosphere now. There are a lot of ions. And we are not going into detail that the ionosphere has several layers again based on the plasma properties. So this ionosphere can also be divided into several layers. Right? So we normally call it D, E, and F, and there are a lot of details when the students I'm talking about, if you are interested in like space sciences, there are several places where we study this Earth ionosphere. And the reason we study, because this Earth ionosphere is extremely important in terms of like satellite navigations, the satellite communications, and so on, many things. Right? So that's why it is quite interesting to study. And there are sometimes what happens in the daytime, nighttime, the plasma instabilities, the change in the densities occurs, and that is where the signals, the satellite signals get disrupted. So that is one of the things we should study because of that. Right? So anyway, so daytime, the ionosphere, the densities are quite high because the sun is continuously pumping energy, and there's a production of ions and electrons. By the night time, you see that the densities decreases because there is no productions. So the ions and electrons there, which actually was produced in the daytime, now try to recombine with each other. And you see this is the reason. The densities, the electron density or plasma density, we call it, it is decreasing in the night. All right, so that is the normal tendency, normal trend in the ionosphere. So now, we study these things, of course, but now thing is how to study all these things, how to measure this. Okay. So there are several types of measurements. Okay. So several types of means we can measure in situ measure, or we can do in situ measurements. Means we have to take the instrument and we have to go there, that particular place, and take the measurements. Just like we measure our temperature using the thermometer, right? So you just put a normal thermometer and just we take the temperature on our tongue, in the below tongue, and just we get temperature whether we have a fever or not, right? As you know. But there are sometimes there is no need to take in situ measurements. All right. So in situ measurements are important, but at the same time, it is very difficult sometimes if it is a remote place, for example. For example, this is at 200 kilometers. How to go there, first of all? It is difficult to go there, right? Sometimes it's impossible to go there. How to go there? So that is why, it is not very, all the time, if you take measurements, it is impossible to measure as if you have only in situ measurements. That is why these remote sensing measurements are very extremely important. Like almost I can call it 99.99% measurements, whatever we are taking is because of remote sensing measurements. Very, very few measurements we took using like in situ measurements, like for example, either through satellites or sounding rockets and so on. So I'm sure that you guys know about satellites and sounding rockets. So ISRO regularly send rockets and take measurements of the ionosphere, atmosphere, and so on. You might have, some of you I'm sure might have noticed as well. Right? So there are two types of remote sensing measurements. It's called active and passive. So active means we send some signal and receive some signal and receive the echo of it. So signal, we send some signal, and then there's some scattering, and the scattered signal we dissipate by the receivers. And the passive remote sensing means we only collect signal, we don't send anything. So there are some, like you can call it like natural signals, they emit, and we just collect them, that's it. So there are several types, I'm not going into the detail of it. So for example, one of the active remote sensing signal, remote sensing measurement is called radar. So radar in acronym is the radio detection range. So for example, you know that radar, like it sends the aircraft, means you can from this signal which is sent from a transmitter, it bounces back from a aircraft and it receives it, and from there we can call it that where the aircraft is, in which directions the aircraft is going, and so on. Things. A similar way, we have atmospheric radars. Sometimes it is called soft radars. So atmospheric radar means the same way we send signal, but now the scatterer is not an aircraft. The scatterer is basically atmospheric atoms and molecules. And from the properties of the scattering, we can get to know many things. Like for example, wind, then temperatures, then so many other things we can measure using atmospheric radars. And many of the observations nowadays, the continuous measurements are being done using atmospheric radars. I mean, you might be knowing that, like in the airport, there are a lot of radars you can see, and there are a lot of radars utilized by ISROs and then IMT and so on. So they use kind of these signals to measure many things. So for example, precipitation rate, whether there is a rain or not in front of that, and all the aircrafts in front of the aircraft, there is a small radar that also detect whether the aircraft is going through a clean region or not. If there is a disturbances, that radar quickly alerts actually the pilots. Okay. And then there is measurement-wise, ionospheric measurement-wise, we call it like radars who can actually sense the plasma density in the ionosphere. So what happens? It sends the radio waves, and based on the property of the radio waves, some of the radio waves can be bounced back, and some of the radio waves can be penetrated through it. Okay? So both are sometimes useful. Both are useful. So some radio wave, it depends on the frequency. Some radio wave frequency will be reflected by the atmosphere and reaches the satellite above the atmosphere. Okay? So both are important, and from both the signal properties, we can get to know many things within the atmosphere. But sometimes what happens, as I told before,
I think so.
It looks like it is suddenly gone, right?
Yeah.
Okay, so how long I was not there?
No, you were there. Suddenly the screen was removed.
Okay.
You were there, I mean.
Oh, okay. All right. So I don't know whether you got to know this this slide or not. Just repeating. So this is atmospheric radar means. Okay, I was just there, right?
Yeah.
Okay. So the ionospheric measurement wise, you see that there are some frequencies which can be reflected by the ionosphere, and some frequency will be going through the ionosphere and reaches the satellite. And you see, this is the region where the ionospheric, it looks like stable, but some processes which makes this ionosphere unstable. And then some of the signal which is supposed to go through this communications purposes, it may get disrupted. So that is why that studying this kind of properties of ionosphere and processes of ionosphere is quite important. And there are some, like we call the measurements wise, the ionosphere measures some at some particular frequencies. We call this the HF frequencies, and these the measurement instrument is called ionosonde, or sometimes we call HF radars. So HF radars basically measures the property of the ionosphere. All right. I'm not going into the detail of it. It's basically sweeping radar. So it sweeps the frequency between nearly 1 to 23 megahertz and so on. And then it basically relies in the properties of reflections of radio waves using plasma, or using natural plasma, or it's called ionosphere. So based on these properties, we know the electron densities and so on, then other parameters as well. The maximum electron densities and maximum electron densities, or maximum altitude, where the maximum electron density is there, and so on. All right. So these are things we can measure using ionosonde, or we call HF radar. So this is the picture of, you can say, the photo of ionosonde. This is a basically transmitter and the receivers as well. Okay? And the data looks like that. So you can see that ionosphere. I mean, so it is. I mean, we can get the the maximum up to maximum altitude, the traces or even the echoes from the maximum altitude. Okay? So beyond that, it is difficult to get it. It is not possible to get it beyond ionosphere, beyond maximum altitude. The data is called ionogram. And there are other measurement techniques called coherent radar. So the coherent radar, basically nothing but the radar technique which actually add the signals of, like, the signals, if the signals are in phase, so we add it and the signal strength becomes more, and then we can do some meaningful sciences. And this coherent radar basically relies on the Bragg scattering of radio waves. So if the radio waves scale size is a certain that it can, depending on the wavelength, you can have a Bragg scattering. And if there is a Bragg scattering, all the scattered waves basically are in phase. And when we add it, so since it is in phase, so the amplitude gets enhanced, basically the power gets enhanced, and we improve the signal to noise ratio, and basically we get a better SNR in a way, so to do meaningful science. Okay? So there are also called MS radar, is called mesospheric, stratospheric, tropospheric radar, which measure with the measurement of many things like wind temperature in the lower atmosphere. Then in the upper atmosphere, we can also measure ionospheric parameters as well again. So this is an Indian MS radar. So it is situated in the southern region, southern part of India. Is called Kiran. So it's one of the ISRO center there. So they have a lot of radio instruments, radar. There are a lot of radar. There are other types of radar as well. So they do all sort of studies. They are expert in radars, radar technology. So there are other techniques called incoherent scattered radar. So like coherent scattered radar is just like opposite of it. So I mean, they don't care about this incoherent scattered technology. Do not care about any whether it is the incoming signal or the scattered signal are in phase or out of phase. So they have technology to receive to all the feeble scattered radiations. So they have the technology. So only thing is that it is really, really difficult to make it, and it is really costly to make it as well. Okay. So one of the radar was in Arecibo Observatory. Arecibo is basically in Puerto Rico, where you know that it's a Caribbean island just beside Cuba, or you can say it's a nearby West Indies and so on. That place. Okay. It's close to South America. I mean, between North America and South America. And it was there before. You can see that huge amount of dish was curved. I mean, it is a naturally curved. The place. I mean, you can see the natural valley, and this valley was curved into a dish. Okay? And the diameter is something like 300 meters. See, so diameter is 300 meters. So you can imagine how big it is. Okay? So, but unfortunately, recently, 1 or 2 years ago, it got destroyed actually because of certain things. All this cable ties, and they suddenly collapsed eventually. But now they are trying to make a new one. And this Arecibo, this radar actually, it was featured. I mean, you can see close look. and that was featured in one of the movies. If you people have seen James Bond movies, GoldenEye, so this movies was actually featured this radio telescope. Okay? So you can, if you want, you can watch the movies GoldenEye, James Bond. Okay? And actually, it was I mean, the shooting was carried out there. Right. So now let us come to the place where actually now we are doing what we are doing here. Okay? So as you know, this is the world map, and this is India, this is Sri Lanka, and so on. And the Roorkee is somewhere over here, even northern than New Delhi, okay, in Uttarakhand region. And Hubli, I'm sure, was somewhere over here, right, in Karnataka. So this is the place. You can see the black dotted line. So it is basically nothing but the geomagnetic equator. Okay? It is not a geographic equator. Geographic equator is this, the straight line. So geomagnetic equator, and this geomagnetic equator, I mean, it is not a very constant. It changes. Like the position of the geomagnetic equator, it keep on changing with time. Like, but it is very slow. The drift is very slow. For example, right now it is here. Okay? Maybe after 20 years, 30 years, it will be drift either to this directions or this directions. Okay? Because of this, the dynamo in the Earth's core, because that is also dynamic. So that is why this is also kind of a dynamic. Okay? And this geomagnetic equator is very important because all this plasma, which is actually sensitive to Earth's magnetic field, they gets like influenced by this Earth's magnetic field, and the geomagnetic equator plays a vital role. And it is like you can see, this is the red dotted line over either side of this geomagnetic equator. These are called equatorial anomaly crest region. I'll tell about it. I'll talk briefly about it. Okay. All right. So this is called the equatorial ionization anomaly. So here it is basically the equator, and the magnetic field is in such a way that because of this magnetic field, there is an additional electric. I mean, independently, the electric field can be generated in the region. Okay, I'm not going into detail of how it is generated, but electric field is generated in this ionospheric region, and there is a magnetic field. Okay? So this is southern region, this is northern region. Okay? It's a north pole is somewhere over here, south pole is somewhere over here, and this is magnetic equator. Okay, not a geographic equator. I'm telling magnetic equator, geomagnetic equator. And on this geomagnetic equator, you can see the magnetic field is almost like horizontal. And beyond that, the magnetic field is not exactly horizontal. So over this magnetic equator, what happens? There is an electric field, there is a magnetic field. And if there is an electric and magnetic field, and there are charged particles, there will be E cross B drift. Okay, E cross B drift. As you know, I mean, if you're physics students, you know the E cross B drift. And this E cross B drift is acting vertically upward. Because the magnetic field is northward and this electric field is east-west direction. So basically it is going upward directions. And this upward direction is taking all this plasma, like sucking plasma in this region and pouring it over here. Sucking plasma in this region and pouring it over here. All right, that's how the plasma is flowing along this magnetic field and going towards equatorial region. All right, in both the sides of the equator. In the southern region, southern side, southern hemisphere, or I should say the southern part of this equator and the northern part of the equator. Okay. And this is actually a real picture, or you can say the real situations is measured by some satellite. You can see the plasma densities. Okay. This is the false color. The color code is basically density, plasma densities. The plasma densities are basically more over the off-equatorial region, just because of this phenomenon. It's called fountain effect. And this fountain effect is basically we see this off-equatorial region. And this fountain effect actually was discovered by an Indian scientist, S.K. Mitra, long back in 1940s. He predicted it, actually, to be very honest. Okay? And he's the, he started actually the space sciences in India. And as you know, Dr. Vikram Sarabhai, he started the space technology in India. So these two persons were responsible for, like, you can say, the fathers of Indian space science and technology. All right. So this fountain effect causes the plasma to go off equatorial region through magnetic field. All right. If there is no magnetic field, these things will not happen. Okay. And that is why our things comes into picture. Okay. So the same thing, like geometric boundary and so on. So basically what happens, the plasma from this equatorial region is pouring to this region on either side of the geometric equator. It is something like nearby. So if you go to the latitude wise, so the Kolkata, then Ahmedabad is all are falling under anomaly crest region or equatorial anomaly crest region. Okay. So the plasma goes up to mostly up to this. Okay. So beyond that, it is not. So everything is like own, you can call it, it depends on the strength of the electric field. Magnetic field is almost constant. So depending on the strength of the magnetic field, it can go some region. So that is up to like most. Sometimes it goes beyond Ahmedabad. It may reach to New Delhi as well, even northern or even southern than this. But in general, in normal conditions, it is like up to Ahmedabad region. Okay. So now our thing is that we should, the region where things are getting important is, you can see that Ahmedabad is region over here. So what we did now, we went to a place which is beyond geomagnetic crest. You can call it the equatorial crest anomaly. So beyond that, okay? So which is not controlled by now equatorial processes, because within this region, up to Ahmedabad, you can call it, the whole thing is basically controlled by equatorial processes. Now we don't want that, so we have to go beyond region, and one place is called Hanley. And since we are interested basically optical measurements, so we have to go to a place where the sky condition is good. Because sky condition is, otherwise if there's also a sky condition is bad, then you cannot afford to do any optical measurements in the sky. All right. So one very ideal place is Indian Astronomical Observatory. It is an observatory which has a host of telescopes. And one of the biggest telescopes is called Himalayan Chandra telescope. And it is this observatory basically run by Indian Institute of Astrophysics, Bangalore. So all these Hubli guys, so it is Bangalore is somewhere over here, right? It's very close to your, not very close, it is closer to your place. All right. So these Indian Institute of Astrophysics, they have established one observatory there at Hanley, Ladakh, you can call it. So Ladakh is somewhere over here. And we went there to install our optical instrument. Which type of instrument will come down? So before that, we just want to say that there are other instruments also. Like for example, ionosonde in New Delhi, which I already talked about it. Then HF radar over here at Badanki. Then also GPS receivers over at Hanley and many other places. So the GPS receiver, what it does, so it basically takes the signal, just like in the ionosphere I told you several times. There are so many GPS receivers, GPS satellites, and the satellite, we get a signal. It is a passive instrument, passive remote sensing. So it receives the signal from the GPS satellite, and it estimates the total electron content along the path of this satellite ray. Along the path of the satellite signal, basically. So if the satellite over here, it takes this path to go there, and along this path, what is the total electron content, we can measure it. If the sunlight is over here, and if you get the signal like this, so that the total electron content or TEC will be like that. Right. So there are this formula, we're not going into the detail of it. And this GPS, this mostly we use dual frequency GPS for calculations of this total electron content, which works in an L-band frequency. So one is like 1.5 megahertz, another is 1.2 megahertz. Okay. So L1 and L2. Anyway, so there are other things are there. It's called ionosonde. I already talked about it. There are HF radars. So these are also there at Gatangi. So that talks about the possibilities of any equatorial processes, equatorial ionospheric processes. Okay? So that is the possibility whether it is there. I mean, something is there or not. Just to include or exclude the possibilities. Or say it works in it like 30 megahertz. So that is why we call it HF radar. So now let us come to things which we do. So here you can see over in the Google map. So the observatory is over here, and observatory has two parts. One is the base camp, and the base camp itself is situated 4,200 meters from mean sea level. It's a huge, I mean, you can say, and this Hanle region or Leh Ladakh region, basically it is, you can call it the cold mountain region. So the terrain is like that. It is just like a mountain desert. Okay? There are a lot of sand. You don't find any vegetations there. It's only a sand, the cold mountain desert, you can call it, because it's just a sand and nothing else. And that is the reason the humidity is very, very low. It's like 40–50% relative humidity. And the ambient pressure is only 600 millibar, because at so high altitude, it is even like very, very less and very difficult to breathe sometimes. And there is another site where there is a little bit more altitude. There is peak altitude is something like 4,500 meters. And there, that is all the telescopes are situated there. So we did not install our instrument over there. We went to base camp, so over here. And there are other institutes, for example, the PARC, the TIFR. They also have the gamma ray telescopes situated over here. And India's biggest gamma ray telescope is being constructed nowadays over here in this region. And the whole, like the campus, you can call it, is under solar power. It doesn't have any commercial power. Normally we have in your household. It's all are under solar power. And you see, this is a solar array. This is one big solar array over here. This is a big solar, another smaller one over here. Okay, so the whole campus basically is under solar power. Okay? And it is not a very good place to go. I mean, it is very difficult to go because you see the 40% less oxygen. So it's very difficult sometimes to breathe in it. So you need few days of acclimatizations in Leh, and then you have to climb to Hubble. So this is the actual real picture of it. Just you can see. This is the place. You can see there are few small telescopes. This is the one. And our place is this. We made a small housing over here. And this is the place. Right? This is the actual place we made. So this is a place where we made. So we made it from scratch. So we took all these things over there and made by some of our contractors. And you see, this is a weatherproof housing. It's a container which keeps the instrument over there. Okay. So now thing is that what type of instrument is installed there? So we call it the all sky imager. It's an imager. Nothing that is imager. It takes basically photograph of the sky at very, very wide angle. So the wide angle means it is almost like 140-degree field of view, very wide angle. So you guys have all like SLR camera, DSLR camera, right? And you sometimes want to take photo in a short distance, but take the very wide view, wide field of view. So you have lenses, you just attached it, and you have very wide angle photograph. So same thing here. Even I mean, quality was even better than that, of course. So it has huge, like 140-degree field of view lens, and there are some filters. We'll be talking about it, and there is a CCD camera, basically. So it takes the photograph of sky during the night time. And the filters I'm talking about, these filters are basically the passive remote sensing, which we talked about a few minutes ago. The passive remote sensing is nothing but we capture some naturally emitting radiations. And those radiations can be captured by this type of instruments. And this type of instruments, which we have, we need a filter to make it more robust, because all types of wavelengths are coming, like right from UV to infrared. So we just want to stop those unwanted signals. So that is the reason we wanted some specific signal, and this specific signal can be captured by can be selected by the filters. Okay. So there are a few filters out there. So one is green line filter, and it's red line filter. Okay. So these two emissions, basically, this green line and red line, these are coming from separate different altitude regions. So like green line, it comes from around 97 kilometers of Earth atmosphere. Okay. And this red line is coming from 250 kilometers of Earth atmosphere. So this is what the image analysis, there are a lot of image processing that are done. Okay. So those who are interested in like algorithms, developing algorithms, so there is also a good place to do that. Okay. So this, you can see this all sky image, you'll see a lot of stars, right? And using the stars, we can now calibrate the image. So if you take this just a photograph of the sky, it is very difficult to say which is north and which is south, or which is east and which is west, unless until we recognize the star. So using the recognition of stars, we know which is north, which is south, which is east, which is west, and do many other complex analysis. We get to know the latitude, longitude of the places. So I'm not going into the detail of it. And from this place, we do a lot of studies. Okay. So when this image is projected on this plane, so before that, we know that, you see that here is Handlet, and here is our place, IIT Roorkee. So the data is captured over here, then they were sent to us. We have a server, we'll talk about it later. So basically what happens, this image actually, if you project it on 2D plane, basically, and we do the geospatial calibrations, then it looks like this. This image, you can see, it's taken at the red line. It is the CCD is basically a black and white CCD, monochromatic CCD. So that is the reason it is like you don't see any color in it. Okay. So you can see the Indian map, Hanleos over here, New Delhi's over here. Okay. And we are, Roorkee is somewhere over here. So it captures up to that region. So whole Ladakh and Jammu Kashmir is taken care, and some of the part of Nepal as well. Okay. The whole thing is being covered by this region, and some of the Tibet region as well. Right. And this you can see that the dark region and bright region of the intensity. Basically, this is nothing but the intensity of these emissions. And the beauty of the emission is wherever there is intensity is more, the plasma density is also, we can tell it is more, because the change in the intensity is proportional to the change in the plasma density. That is the beauty of this emission. Okay. So that is the reason we choose this emission to study plasma in the ionosphere. All right. So there are a few results, of course, some interesting results. I'm not going to the detail of it. So there are some results which recently observed, which is never seen before. So this type of results over here, you can see the dark region. It's called plasma bubble, we can call it sometimes, or plasma depletions. these can travel from one place to another. You can see this is the plasma depleted region, which can be generated in this and then can travel and sometimes disappear. There are some other types of plasma distributions or plasma, like plasma waves, you can call it, that also travels from one place to another. So just these are pure science things and pure like physical phenomena happens. I'm not going into the detail of it. So that is what the data sharing web portal, as I told, this is the server which we have. So if you want, you can go through this login and you can see the data. I mean, even the March 2022 data I can even see over here. You go to the All Sky data, this tab, and you can see the data actually. You cannot download it. If you want to download it, if you want to use it for your science purposes, so you have to write to me. Otherwise, you can see, you can just visualize, I mean, you can view the data basically. Okay. And there's some details of the All Sky images, some the details of the specifications of that, all sort of things are available. Okay. So this is actually the image of building. So this one will be giving the ground support for ISRO's next sun or solar observatory missions. Okay. So it's called Aditya. You know, many of you know that ISRO is going to launch probably this year that one solar observatory, space-based solar observatory. It's called Aditya L1 mission. So one solar observatory, it has a lot of instruments on board, and it will be going to the first Lagrangian point of the Sun Earth system. Okay. And it will measure all sort of solar parameters, solar wind parameters, and there are so many things. There is a solar coronagraph as well. So that will measure the sort of CMEs and so on. And this, the disturbances from the sun or CMEs, coronal mass ejections, and all the high energy solar wind parameters, plasma, it reaches Earth's surface and creates disturbances in the Earth atmosphere. So sun and Earth are all linked together. So we'll be giving kind of a ground support for Aditya 11 missions because you know the sun is getting now active. Sun is becoming angry, you can call it. In layman's language, you can call it sun is right now, sun is pretty much quiet and it is preparing for its activeness, it's becoming angry. So that time we get a lot of solar wind or high energy solar particles that reaches Earth's surface. I mean, sometimes Earth's surface, sometimes in the ionosphere itself or in the atmosphere itself, there are a lot of phenomena. So basically things are getting coupled. And I will be giving this kind of a ground support for them. There are a lot of instruments that can measure the things over here at the L1 first Lagrange point of Sun Earth system, and then after some time it reaches also the Earth's atmosphere. So we have we may have some interesting phenomena. And that is why we have our, like this is the server we're talking about. Then we have a lab in Department of Physics IIT. There's one of the building, there is another building as well. So it's a group. And then we are also involved in ISRO's proposed twin satellite missions called DISHA, Disturbed and Quiet Time Ionosphere Thermosphere System and High Altitudes. Okay. So this is called DISHA. It's a twin satellite missions which will measure all those like lines or all those emissions from Earth's Earth atmosphere. Okay. There are other there is one of the payloads. There are other payloads as well, other instruments on board DISHA. So one of the payload is I am involved is here. So basically, it is a twin satellite missions. One will be in the low inclinations, another will be in higher inclinations, and we'll measure many things. And then our group is also involved in like ISRO's proposed planetary explorations, like for example Venus. So one of the instrument is called like you can call it Venus Atmospheric Spectropolarimeter or VASP. Is being developed at present at UR Rao Satellite Center, and we are also involved here to calibrate the test of these instruments. Right. So these also are one of the opportunities nowadays because ISRO is now trying to push for planetary missions. It will be Venus missions. There will be probably MOM2 mission. Mars Orbiter Mission 2, then there can be other missions as well. And you know that the Chandrayaan 2 is anyways going. So there are so many like moon missions and planetary missions are coming up. So there is a lot of opportunities here in terms of planetary atmosphere and solar system. All right. And that's it. And if you have any questions, I'm happy to answer them.
Thank you very much, Sir Paul. And it was great to have a young faculty member like you to encourage students. I'm sure students will definitely take up interest in the domain of space science to make their career in this domain. So session is now open for questions. If there are any questions from participants, and students can also ask questions in their mother tongue. Their professors can translate students' questions.
Yeah, sure. I'm happy to interact with the students. And there are a lot of opportunities I'm talking about. There are a lot of opportunities in space sciences. So those who are doing PG, like postgraduate, and like in first year or second year, or your MSc or MS program. So there are a lot of opportunity if you do PhD.
I think the research scholars who are attending this program, they can join hands with Professor Sumanta, because IIT Roorkee is doing a lot of work in space science and technology, and they got space and space science technology cell at IIT Roorkee in 2019, and they are doing research in various fields, in the field of mechanical engineering, civil engineering, earth sciences, physics, and various other departments. So good opportunities are there. Or those who have already done their MSc and like to do more further research work, they can be in contact with the Professor Sumanta. And I came to know that IIT Roorkee is also planning a student satellite. There are some homework they are doing on this. Students are free to ask questions. I think people from Hubble especially, they are very shy. They are not asking much question. You can ask in your regional language. There are people here who can translate.
And you see, I'm just telling you, even if it is a foolish questions, just ask. Don't fool. I mean, don't think that you are asking foolish questions. It's fine. As long as the questions is okay. So I'm happy to answer it. So don't feel shy. Ask whatever you want.
I have a question. Is it possible to get the depth of air glow?
Can you be a little bit louder, please?
Am I audible now?
Yeah, now you are.
Yeah. I just wanted to know, out of just curiosity, is it possible to have the depth information of the air glow from the ground-based measurement?
No, because depth information you asked, right? Am I correct? Depth informations, right? So are you talking about depth informations?
I mean to say the air glow at what altitude it is formed.
Okay. So basically, you see, as I told, the green line and red line, the different types of air glow, different wavelength of air glow, they are coming from different atmospheric regions. Okay? So you can ask me, how do you know it? So it is from model and then rocket measurements or satellite measurements. So we know that this green line is coming from 97 kilometers. This red line is coming from about top of that are like 250 kilometers. And there are other regions, they are coming from different regions. So that is we know it, it's already known. So the only thing is we don't know about their like why they have this kind of temporal variations there, and how the plasma and these things can generate, and also the things. Okay, so the height wise, it doesn't change much. It does change, but it doesn't change much. It's like the maximum altitude is like, for example, the red line. These are coming from 250 kilometers, and which is nearby few kilometers, plus minus kilometers. Okay. But there is of course, there is a band like 250 kilometers plus minus 40 kilometer region. From there it is coming.
Also type their questions in the chat box.
Okay.
If participants are interested to contact him on his email, and there are a lot of opportunities for students and youngsters the domain of science and video measurement. So we feel very fortunate to have you as a part of this awareness webinar. Thank you very much, sir, for joining us for this session.
Okay, thank you very much.
Dr. Praveen join. Yeah.
Yes, sir, I am available.
We have is by Dr. Praveen Thakur, who is secretary at IRS, which is
Indian Institute of Remote Sensing, Dehradun.
Of Remote Sensing, Dehradun, and he's going to share with us about the activities of Indian Society of Remote Sensing with students, which will help students to get in touch with the society, and if students are interested in remote sensing, they can have an interaction with IRS. With that, I will officially introduce Dr. Praveen K. Thakur, who is currently working as scientist engineer, SG head, water resources department. He completed BTech in civil engineering from National Institute of Technology. Masters of Technology in Water Resources Engineering from Indian Institute of Technology, followed by a PhD in Geomatic Engineering from IIT Roorkee, and then he pursued a space studies program from International Space University, Strasbourg. Then he joined IRS Dehradun in 2004 and has more than 18 years of professional experience in the field of water resources, geospatial technology application. He has published 85 papers in peer-reviewed international journals, 10 book papers. His current research are geospatial application in water resources, microwave remote sensing for snow, ice, and flood studies, hydrological, hydrodynamic, and groundwater modeling, data assimilation, and planetary remote sensing for ice and water cycle studies. He has contributed as principal investigator in 8 research projects and as a co-PI in 4 projects sponsored by ISRO, and as PI in 4 announcement of opportunity projects sponsored by international space agencies such as ESA, DLR, and JAXA, respectively. As a part of these projects, He has conducted many field surveys in Indian river basins and scientific expeditions in Indian Himalayan glaciers and polar regions of Earth for scientific data collection. He has actively participated as a member of the Indian scientific expedition to Antarctica and Arctic in the years 2016-17 at Svalbard, uh, the Arctic during March-April 2019 respectively. He is a science team member of NASA ISRO NISAR mission, NASA ISRO SAR, collectively called as NISAR mission, and he has contributed as science team member for the upcoming surface water ocean topography mission. He was expert member for NDMA Government of India sponsored committee on National Disaster Management Authority guidelines, management of glacial lake outburst floods in the year 2019-2020. He has guided more than 36 MSc, MTech, postgraduate diploma thesis, 3 PhD students, and currently supervising 6 PhD students. He is life member of 7 professional societies related to remote sensing, civil engineering and water resources, ASCE and IWRS, and hydrology, hydraulics and meteorology, IAHS, ISH, IH, and IMS. He has served as treasurer for ISRS Executive Council and at present serving as secretary ISRS in the Executive Council. He is recognized reviewer for many reputed national and international journals in the field of remote sensing, water resources, hydrology, cryosphere, and natural hazards. He is associate editor of Frontiers Journal on Water Resources Management and Microwave Remote Sensing. He is recipient of ISRO Young Scientist Merit Award for the year 2014 and NASA Team Award for NISAR Den Down Selection Team in the year 2021 and ISRS PR Pishroti Memorial Award for the year 2021. Sir, it's a great pleasure to have you with us, and I'm sure that students are excited to know about the activities of Indian Society of Remote Sensing. And with this, over to you, sir.
Thank you, organizer, especially Dr. Mathur, for inviting me to give a small talk about the various activities of Indian Society of Remote Sensing. So I'll be giving a brief information and talk about this our society. Symposium and various awards are given to the under various categories, senior to junior, and also each year we have Vikram Sarabhai Memorial Lecture during these conferences. And from 2016 onwards, the students can go to our website, the ISRS website, and they have been hosted there, and the YouTube links are also available. Then we have very strong international linkages with ISPRS, the ordinary category member 8, which is the highest category among ISPRS, and also the Asian Association of the Remote Sensing. Then we have a very popular Journal of Indian Society of Remote Sensing, which earlier used to be called as Photo Nirvachak. I'll be talking about that, where most of our research activities are showcased in terms of research publications. And then we have new initiatives with the Taylor and Francis, where books and monographs are published with a renowned international publishing house. Then we have the major events which has happened, ISPRS Technical Commission 5, for which ISRS was the chair, and popularization of the remote sensing large-scale initiative, where on the 12th of August, the National Remote Sensing Day various activities are planned, and also ISRS conclave. Although some of these activities were hampered for the in-person conferences symposium due to the COVID situation, but the online lectures and conferences has given a new medium to interact with the various users and student community in last 2 years. And then there is a dedicated slides where the students or any professional can visit our website and become a member. So I will be showing how you can become a member, how you can access our journal. If you are a member, you will be giving we will be giving a free access to you for the journal. So this is about introduction about the ISRS. It was established in campus of Indian Institute of Remote Sensing, Dehradun. Earlier, it was our institute was Indian Photo Interpretation Institute, which was started in 1969 under 1966 under Survey of India. Later on, it became part of National Remote Sensing Center and now under ISRO. So the headquarters of the Indian Society of Remote Sensing was established in 1969 with the main objective of advancement and dissemination of remote sensing technology in the field of mapping, planning, and management of natural resources and environment by means of organizing seminars, symposium, and publications of a journal, which was earlier it started as a 2 volumes in a year, then 4 volumes in a year. Now we have monthly 12 volumes in a year, and we have from Photo Nirvachak to now it is known as the JISRS, which is in collaboration with the Springer. And then the new initiatives of the bulletin books has also started. So when it started with the 56 members. Now it is one of the premier professional body with over 5,847 members. And we are member of the ISPRS and AARS, which are the two recognized and renowned international remote sensing organization. So this is the overall profile. Now membership has increased up to 5,800. We have 61 pattern members, 43 fellows, and 11 honorary fellows, and approximately around 100 members each year. Sometimes that number can be double also. Join as a life member or as a student member. And now we have a total number of 27 chapters spread over all parts of the country. And to become or start a new chapter, you should have at least 15 members from a particular city. And within 40 kilometers around that city, you can include that, provided you don't have the very nearby some one more chapter, existing chapter should not be there. So this is the latest list of the updated chapters. Most of them have their active executive councils and members, which organize local popularization activities in field of remote sensing, mainly during the National Remote Sensing Day, World Environment Day, National Science Day, Earth Day celebrations, and also participation in the conclave of the chapters and the annual conference symposium of the ISRS. So the main activities are centered around this educational and the annual conventions or the national symposium. And we have our sister organization, which is called Indian Society of Geomatics. They have the headquarters in Ahmedabad. So on alternate basis, 1 year ISRS will organize the event, and one next year ISG will organize that particular main event. And during this, we have the annual award ceremony, and then each year, whether it is organized by ISRS or ISG, we will have the Vikram Sarabhai Memorial Lecture. And then if it is organized by ISG, we will have a special technical session which is organized by the ISRS. And in addition to this, we have the pre-symposium tutorials also in emerging fields, for example, in terms of photogrammetry or large-scale mapping, micro remote sensing, hyperspectral remote sensing, terrestrial photogrammetry, UAV remote sensing. These are some of the themes where pre-symposium tutorials are organized specially to take care of the students who are actually pursuing research in these particular fields. And these some of these lectures, Vikram Sarabhai Memorial Lectures, they are also available in our website. So this you can visualize and learn about these main lectures, and these are the list of awards which ISRS has constituted. The highest award being the Bhaskara Award, which is given Bhaskara Award, Satish Dhawan Award, and Geospatial Excellence Award. So these three awards comes under the senior category, and then Indian Geospatial Award and Pisharoti, which was earlier Remote Sensing Award, under the junior category. So the highest award is the Bhaskara Award. It is a lifetime achievement award given to the eminent persons who are working in the field of remote sensing. So you can see it started with Dr. Joe Joseph to our late Dr. S.S. Day in 2020. Then we have the Satish Dhawan Award. So each year there will be a committee who will be selecting these awards. And for the students, there is a Best Paper Publication Award. And now these awards, earlier it used to be 1 or 2, now under the 4 categories: GIS technology, remote sensing technique. So all these subcategories has been created, and those authors who are publishing their paper in the Journal of Indian Society of Remote Sensing under 4 different themes, annually we are giving this particular award. Then there is a Young Achiever Award, and during the conference there is a Best Paper Award, Student Award, and also poster awards for the students. And in addition to this, I will show in the slides of ISPRS and AARS. ISRS has actually initiated one more award during the annual conference of Asian Association of Remote Sensing, and also we have initiated the donation to the international this ISPRS, where the students or the researchers from India can get sponsorship to attend the ISPRS symposium in future. So, and this is the annual main function when we have this ISRS ISG main annual symposium. During that evening, we have this Dr. Vikram Sarabhai Memorial Lecture given by one of the eminent and expert persons in the field. So the last from 25 to 29, now 30 also, during 2021. So all these lectures and popular talks, they are available online in our ISRS website. So any user, any student, they can revisit and see the thought and the valuable information and the overall policy guidelines what has been given from remote sensing and space-based inputs for the remote sensing community or general public in large. And this is the international linkages I was talking about, this ISPRS and AARS. So ISRS is ordinary member under category 8, and we are the chair of Technical Commission 4 under the Education and Outreach from 2016 to 2020. But this was extended for at least 2 years to 2022. Now we are bidding for Technical Commission 3 and 4, that is from the Remote Sensing Commission and Spatial Information Science Commission. And last year, we also made a one-time donation of $10,000 to ISPRF Foundation, which basically coordinates the activities of the students or the researchers who want to go to the ISPRS sponsored conferences or congresses, and they can support the travel, they can support the registration also. And this year, we will be bidding for the ISPRS Congress 2026. And similarly, ISRS is member of AARS. Now India is part of council member in addition to Japan, China, and Taiwan. And India organized a successfully Asian Conference in Remote Sensing in 2017. And last year, we constituted an award under the ACRS. During the annual conference of ACRS, the award will be given in from the ISRS side to the young researchers who participate in the conference and publish their and present their work during the conference. And this is some of the highlights. The last international conference before the COVID that we organized in Dehradun city under the ISPRS Technical Commission 5. This is the midterm symposium, and it was one of the resounding success, where a large number of speakers, national and international technical sessions, more than 400 papers submitted out of this 213 published, and 3 pre-symposium tutorials were also conducted. But after 2020, there has been less number of international in-person conferences due to the pandemic. And then coming to our scientific communication. So this is the main workhorse or the main journal of Indian Society of Remote Sensing, and it started as a photo nirvachak under ISRS earlier, but now it has fully integrated with the Springer, with the editorial manager, peer-reviewed international journal and it is monthly available from 2018, and it is through the online version only, like you publish in any international journal. Through the editorial manager, you can submit and you can track. And this is also because now we are not sending any hard copy to each of the libraries, but we get the royalty from this journal, which gives back to our society, and that money is used for organizing the conferences. And last year, our impact factor has increased from 0.9 to 1.56, and overall 5-year 1.485. And I'm sure in 2021, it should reach the level of 2+ impact factor in 2021. So in addition to the journal, this is the books and other monographs which are being published under the contract with the Taylor and Francis. It started in 2018 for the year of 5 years, and we will also renew this. And under this, we have the 4 books which has been published, and 7 books are in various stages of the publication and the review. You can visit our ISRS website, and then you can also directly order. Hello. Yeah, you can also directly order from through your library via Taylor and Francis publishing house. In addition to this 4 books, there are 3 more books. One on hyperspectral data by our professor R.R. Navalgund and late Shri S.S. Ray. Then we have Geomorphology of Indian subcontinent continent in ISRS monograph by R. Vaidyanathanji in 2002. And in Hindi, we have one book by our stalwart of remote sensing, Dr. George Joseph, which was published in 2019. And there is an online form also. If any of the researcher or professor or student who are working in their PhD, they want to propose a book, they can put their title, give the list of authors, address, your brief biodata, and can give a sample chapter. So all these new proposals are actively pursued. They are sent to the reviewers. There is a first level of screening, and then once they are passed through that first level of screening, they are sent to the reviewers. And then if the reviewer is positive, then you can further proceed with the publication of your book, either as a single book or as a compilation of invited chapters from various multiple authors. Then, as I told, in addition to the conferencing, the biggest single day event that is celebrated on a large scale is the National Remote Sensing Day. Although there are many chapters who organize their individual activities also, but from 2017 onwards, it was centralized, where the main ISRS will be conducting and all chapters will be joining. And this was one of the first experiment for NRSD, that we call it popularly. And this celebration is also celebrated as a to commemorate the birthday of our founder, Dr. Vikram Sarabhai. So it was one of the big success, where more than 1 lakh joined online mode, and various activities were planned. The list you can see here, and this entire details, all the videos, they are actually available online in our ISRS website. And this also got the DST award for innovative applications of electronic media for popularization of science and technology during 2017. And this is the highlight of the 2018 National Remote Sensing Day, and they are all theme based. In 2018, the theme was popularization of the remote sensing amongst school children, where a lot of poster competition was also organized prior to the main event. And you can see those posters which were created by various students in our website. And then in 2019, it was a celebration of Remote Sensing Day in the remote areas. And this in person also, many people have visited from the local chapters. And in 2020 and 2021, these events were organized only in the online mode. And coming to the website, so this is the main website. So this is our main website where you can see our members, the awards, conference, symposium, publications, gallery, where you will find the link to the video gallery and also the executive council and the highlights of the important day celebrations which were organized in the previous years. And this is the dashboard. Most important for any society is the member. So we value our members, and earlier the membership used to be through a hard copy, the form, it has to be filled and then it has to be submitted, forwarded by a proposer. Now this all process has been automated, and also it is implemented in the online way. You can fill your name, you can fill the proposer's date. Proposer means one of the any ISRS members has to propose you as a member. So you can contact any of the existing members from your organization or from your institute, and then the long life membership or the student membership rates are different, very nominal, approximately 3,000 rupees for the life membership you can submit here. And through the this CC Avenue online payment has been enabled, and once you make the payment within a few weeks, member of ISRS, existing member of the ISRS, you have many advantages. For example, you will have your own dashboard. In this dashboard, you can update your address, and what you can also do, you can also add the latest email, because these days most of the information is either through the email, or in some cases by a call also. So you have to update your contact details, which should be at wherever your work of place is there. Sometimes you may get retired from the job, or you may shift or switch jobs, but your membership, if it is updated, you will get the latest information on a timely basis. And this is the login space where you will get the online membership certificate also you can print. And also one important thing is the Springer journal link, because if you visit the Springer journal from outside the society website, then you have to pay for the journal paper what you have published, or if you want to download some old paper without paying, then you update your address and also access the journal through the ISRS website. So once you have access, you will get the free access to all the journals issues which you are want to see or want to do the research. So for the members, it is freely available. And this is just one example of the membership certificate, where you can print it and then download it as a PDF file. And these are some of the examples of the video repository uploaded on the YouTube. Most of these popular lectures and online sessions, they refer to 2016 day onwards, 2016 onwards, especially for Vikram Sarabhai lecture. And from last 2 years, many of the online symposium and the lectures, even popular lectures, they were conducted in online mode. So those lectures are also available in online mode. And unfortunately, during the pandemic, there has been fatalities among our dearest ISRS members due to especially during the second wave of the COVID-19, and there has been special condolences messages which has been given by our respected President Nilesh Desai under the 2020-22 EC. And apart from this, these are the highlights. The National Symposium, which was the first experience for ISRS to conduct such event totally in a online mode, including the Vikram Sarabhai lecture, the ISRS ISG Awards ceremony, and distribution of even the cultural program. It was conducted in a online mode. It was a first experiment, and it was a very big success. And in 2021, we thought that it will be normal, but then we had the second wave and this Omicron Delta variant, Omicron variant came. So that activity also had to be done fully in a online mode. And in addition to this, there has been a special celebration on IRS-1C launch on 28th December 2020, which we celebrated the 25 years of launch of IRS-1C, one of the very important and long-running satellite of ISRO. And for the 2021, this is the highlights of the National Remote Sensing Day celebrations, which was inaugurated by Professor K. Vijay Raghavan, Principal Scientific Advisor to Government of India, and entire proceedings, including the exhibition and also one important lecture and documentary on our father of Indian space program, Dr. Vikram Sarabhai, is available online, both via our main website, isrsindia.org, and also directly in the YouTube. So the students can enjoy and learn from the life and the works of Dr. Vikram Sarabhai. It is a must watch for all the young students and researchers who are pursuing the space science, especially in Indian context. So this is available online. And then very important lecture during the pandemic in 2021, the Vikram Sarabhai lecture was organized on the topic of biotechnology in India and accelerating journey from research to translation by Dr. Renu Surabji, former Secretary, Department of Biotechnology. So it is not that it is suddenly India started making its vaccine. It is the work of more than 50 years by the Government of India and associated departments like Department of Biotechnology and the other labs, which has worked continuously in making the physical infrastructure, the networking, the other fields associated with the large-scale mapping, monitoring, and also creation of the world-class health infrastructure required to make such kind of vaccines. So I request all the students also to visit this YouTube and learn about the powerhouses of India in the field of biotechnology, and also a special role of space science community, especially the biodiversity portal and other health initiative taken by Department of Space in collaboration with the biotechnology. Then for the ISRS, the new term, this is our new term which has been elected unopposed. And one important thing that we could do because of the pandemic and other associated digital mediums, earlier election used to be conducted by ballot. So we had to amend our constitution, and this has been amended. And now most of our elections will be conducted through online in e-voting based. But this year we could not, we had actually pursued this, but only one person applied for one post. So most of the members were elected unopposed. So there was no need for conducting the elections. Otherwise, this e-voting is in place. So next time when we'll have, so it will be in the e-mode. And for this year and next years, we will have the National Remote Sensing Day celebrations in August, and upcoming Earth Day, Environment Day, and Wildlife Day. There has to be celebration. Then we have 50 years, which actually happened in 2019, but the big celebrations are still to be completed. So 50 years of Indian Society Remote Sensing, and then due to the shift in the main ISPRS Congress in Nice, France, so bidding has to be done for 2026 and also for Technical Commission 3 and 4. and also the annual convention and symposia ISRS, which ISRS will take lead this year for organizing. And for organization and attending these symposiums, there is a student fellowship also, where students get the travel grant to visit these places, symposium, and present their research work. So this is all about Indian Society of Remote Sensing. So if you have any questions, I'll be happy to take.
Thank you very much, sir, for your in-depth presentation talking about the activities of ISRS. So forum is now open for questions. Students, faculties can ask question to Dr. Praveen Thakur.
And I request all the student community to at least join as a student member, and all the senior researchers, they can join as a life member for this our premier remote sensing society, and avail the benefits of the journal, books, and attending the conferences and symposia, and meeting the experts, established experts and young researchers in the field of remote sensing and geomatics.
Thank you very much, sir. Any more questions from participants? On YouTube also. Okay, I'm checking. No. Sir?
Students are reluctant to ask question most of the lectures. Praveenji, thank you very much.
Thank you, sir, for the invitation.
Yeah.
Hopefully next time we will meet in person.
Definitely, definitely. ISRS Ahmedabad chapter is also one of the very active chapters. They do
yes, sir.
a lot of activity.
Yes, the online symposium 2020 was first actually organized by the Ahmedabad chapter only. So it was a big resounding success, which was led by Ahmedabad chapter.
And out of 5 societies which are based at SAC Ahmedabad, ISRS is the topmost, having maximum number and do maximum activities.
Yes, sir. Yes.
Okay, Chintamani, I think you can proceed if there is no other question.
Thank you very much, Dr. Praveen Thakur, for joining us and
your voice also stops. Switch on your mic.
Very much, Dr. Praveen Thakur, for joining us all the way and giving us information about the ISRS and its activities. I'm sure by attending this awareness webinar series, students are inspired to take up career in the field of remote sensing, and they will definitely join the ISRS and its activities. Thank you very much, sir, for joining us today.
Thank you.
Mathur sir, shall we then proceed with the next session?
Next session is a presentation on Indian Meteorological Society, IMS, in which there are a lot of members from scientific field. And that presentation is to be made by Dr. Rajkumar. I don't know whether he has joined. Just can you check up?
Yes, sir. We're online.
Yeah, I'm there.
Yeah, Rajkumar ji is there. So he will make a presentation on the activities of the Indian Society, ISMA, IMSA, IMSA, Indian Meteorological Society, Ahmedabad chapter.
Yeah. Yeah, good afternoon again. So Indian Meteorological Society, as the name itself says, this is the society, mainly National Society, Indian Meteorological Society, which is formed in almost, we can say, 1957 or so, during a session in the Indian Science Congress in Calcutta. And the main role of this society is to make the awareness about this meteorological events or meteorological activities, and about that what meteorology can do. As you know, weather science is the science which is everybody is interested. Everybody is, or we can also say everybody is expert about the weather. Also, if anybody you ask what will be the tomorrow's weather, everybody will have his or her opinion about that. So this is the science we call it. Everybody is science, and everybody is interested about this also, and as well also everybody is having expertise about this also. At least something everybody will say, okay, this thing will be happening tomorrow, or if suppose some cyclone is coming, then even a layman will say, yes, it will be coming tomorrow. It will be hitting at this place, or this will happen like that. So anyhow, that is the beauty of the meteorology itself. But main thing is there about this society, that about that students as well as all these professionals working in this field, or maybe all the related fields related to meteorology. One of the related fields is agriculture, disaster, and oceanography. So these are the fields. The people from all over the country, what we feel they should be working toward that, and they will be attached to this society. So that's why main goal is society is to partner the scientific community in improving the understanding of all this impact of the weather events on, and maybe not only the weather, present weather, or maybe the near future weather, but also the climatic trends on the community itself, or what is the community which is involved, local community, as well as one more goal or objective of the society is to promote awareness of meteorology and climate science about the general about India, like this. That's what this is society. We have almost, I think, presently 32 chapters all over the country of this society, and these are almost many places. Sorry, this is one of the chapter. This is Ahmedabad chapter, which I was looking after till the 31st March. I was chairing that this Ahmedabad chapter. And then we have many other chapters like Allahabad, Bangalore, Bhopal, Lucknow, Delhi, Pune, Chennai, many chapters, all these places where and meteorology, meteorological centers are all over the country. It is there. Every city you go, there is some meteorological center is there. All the you may be knowing all this airports. We have the meteorological center for giving the information about the weather. So that's why most of the places we have these chapters also, and very active chapters are there. Like Pune chapter is very active, and Ahmedabad chapter it is very active chapter. So we do many activities for this awareness of this meteorology in this through the public outreach we do. For that we do the regular lectures about the meteorology in the domain of that, which is the current. Suppose any event is there, then we have that about that current event lectures. And every year, like if I say about this Ahmedabad chapter itself, what we do, we have that one lecture mostly we do about this monsoon event. After the monsoon, that means maybe around October or November, we have the talk on the annual monsoon talk normally every year. What was the monsoon, how it was there, and if any anomaly is there, why it happened, like that. This type of talk normally we have. In addition to that, we have the World Meteorological Day. You may be knowing this is on the 23rd March. Normally it is being observed all over the world, not only in India. So that also Meteorological Society, all the chapters mostly do. So we also do this activity, and that day we do sometime popular lectures or maybe discussions. So like this year, we had a very good discussions, a panel discussion we had on the role of aerosol as well as this water, groundwater on this agriculture as well as the environment, because that is very burning topic. You may be knowing every Diwali time, you may be hearing near the Delhi, we always hear that this is so much biomass burning is there, and because of that your whole event or the Delhi is having a lot of pollution. So that was the one of the reason. Normally we have discussion on this thing, but recently with the panel discussion of the eminent scientists from the groundwater point of view, Director NGRI, Dr. Tiwari was there, and then from the agriculture, Professor Saigal from Indian Agriculture Research Institute was there. Then one of the professor from the IIT Kanpur, Dr. Tripathi was there, as well as the Director of Indian Institute of Remote Sensing, as well as the Director of National Remote Sensing Center, Dr. Prakash Chauhan. So these people were there, a panel discussion. They talked about that why this it is happening, what is the biomass burning is, why it is happening, why it is started, what was the reason this thing it is coming nowadays is a very large scale it is happening, and those days what is the probable solutions we wanted to discuss. So these are this is the just one event I was talking, the recent event we have on this. Then we have normally with this all other societies, because we have an Indian Society of Remote Sensing, that also Ahmedabad chapter, Indian Society of Geomatics, Indian Cartographic Society. So we do a joint event also for this all this related events like World Environment Day, World Water Day. So like that we have Geospatial Day. So all these events normally we do during a whole year. And also we have since 3 years we started on this competition which is called the Monsoon Photography Contest for the young school children as well as the college students as well as professional. In that during the monsoon period, all this whoever want, they can take the photographs, very beautiful photographs they can take on their own, then send to us, and then we have this set up a panel of experts. They decide which is the best photograph, like that we do. So that is one of the activity we do. In addition to that, normally other lectures we do go on doing. One another thing we had started one lecture series which is called the Professor Satish Dhawan lecture series. So under that series also we have this all the lectures by eminent scientists. Similarly, other event also like World Ozone Day and all those event also normally we do this during this period. In addition to that, one of the activity I can say which is started by Ahmedabad chapter itself. One is the if anybody of you from this field or maybe knowing meteorological field and related field, we have a symposium, annual symposium. It's called the TropMet, Tropical Meteorology. The name is Tropical Meteorology actually. 1992 we started this symposium from the Ahmedabad chapter itself. It was started, and then that was a very great success event. And then after that, different chapters now every year organize this event. In that we have sessions on the various topics on the weather, ocean, atmosphere, climate, remote sensing, many different topics we have from all over the country. This TropMet symposium we have, and then after some time, maybe every 4 years or so, depending upon that, if any chapter is taking more interest, we have an international symposium, what we call it Intromet. That also we have, and then that symposium also we had actually in 2018, I think, in or 17 in Ahmedabad itself. Instruments 2017 we had with the help of a Space Application Center and all other centers. So these are the some events, and what also do we go to the many places and like exhibition we used to do with this our instruments, and 3 years back we had got some small instruments, that weather instruments, and we had given to the school students actually, and then so that like rain gauge, small rain gauge or the temperature, students can by that they learn also and they can do experiment. So this type of things we do. Actually our aim was to this through this experiment school students like a whole monsoon at their home or their school, they can have the measurement of this rain, how much rain is happening every day or like that, or the temperature, how the temperature variations are there. So they can, by that they will get interest also. Okay, in my place this much changes are happening, and by that they get the more interested. And we wanted to have suppose 30-40 schools. We wanted in a rural area as well as near Ahmedabad, because Ahmedabad chapter organized it. So we wanted to have a competition between all these students, and then they can talk about that, about their observation, suppose in the form of the graphs or presentations. What were their observations by this, and how they feel about why it is happening. First thing is observation itself. Suppose temperature is daytime around what time it should be increasing more. It should be 2 o'clock, 4 o'clock, or 12 o'clock. Or why it should be at 2 o'clock? It should be more. Why not at 12 o'clock? Because 12 o'clock, if for small children, why it is not 12 o'clock? Supposed to be 12 o'clock. Why it is happening 2 o'clock? Why it is happening 4 o'clock? So that type of curiosity happens for the small little children, and for more younger children or one knowing more about the science. Then they see a trend, how the trend is happening, or suppose rainfall is there, why rainfall is having a particular region even more. Even if you see in the particular locality itself, in a city, somewhere you will hear that rain is happening, other place not happening. So this type of variability also of the rain, why it is happening and what is the reasons. Because of the suppose construction is more in the area, that is because of that rain is less, or wherever the more greenery is there, where temperature is less, temperature it is cooler, and then more rains are there. Such type of things. Also, if we have a different observation at different places, such places, they can come up with their observation. They can discuss. We wanted to have discussion in a one day, 2 day seminar. So they students discuss themselves also. They get idea. Yes, this may be the one of the reasons. So such things also we do normally through the experiments. Also, we have sometimes competition of this drawing competition for this children, or the essay competition. 2 times we had an essay competition for the children or for the school, for different schools. So these are some of the activity. Mainly the what I want to say, the reason of all this, so that children as well as the younger generation or younger professionals, they get more and more interested in these things. So this we do, and we have actually main chapter, what we say, the headquarter India Meteorological Society. They have one journal. It is called the Mausam. You may see in the Indian Meteorological Department. Normally, through that it is published, and one newsletter also they publish, what is called the Vayu Mandal. Through that you get all these news and all those things in this about that meteorology, what is happening, or events, or maybe small talks about the or maybe in some topics they can people write about that things also. So these things they do normally this through Vaimandal. Similarly, in this our Ahmedabad chapter, we have a newsletter which is called the Megha, and since many years it is coming out regularly, and now we have this issue. You can see on this issue on this our website. Our website is imsa.net.in. Just I can share a screen if possible. Yeah, you're able to see my screen?
Yes, sir.
Yeah. So this is this site name is, you can see, the imsa.net.in, and this is the latest issue, winter issue, what we call it. It released March itself, a few days back only. If you see this newsletter about that, first thing is the chairman letter, secretary's report. But beauty of this thing, you see about we had recently we had a lecture on this on the by Professor B.N. Goswami, who are a well-known expert in the meteorology and climate sciences. So we had a lecture by him on the Nobel Prize on the physics, because this time you may be knowing Nobel Prize was on the climate also. So and one of this scientists who got the Nobel Prize, he was guru of Professor Goswami. So Professor Goswami actually talked about the Nobel Prize that. And then this I was talking about this role of groundwater agriculture, air pollution. What we have a panel discussion so about that also. What is happening in that we were talking. Recently we had this elections of this, and we have a new executive committee members of this Indian Meteorological Society. Dr. Rashmi Sharma is now chairperson. Dr. Sanjeev Dev is a secretary. And then if you see this newsletter, very interesting newsletter, you see the about this meteorology. One of the theme, title was the climate change, the dynamic system, advanced space sensor for ocean studies. And then about the fog in the 2021, you know, the every year we have a fog event during November, December. So this time why fog was not there, or what it was less, that about that one topic is there. And one of the interesting topic, if you see about the new nomenclature about this what we call it clouds. So cloud, if you see new nomenclature, the Hindi names of this nomenclature. Dr. Pradeep Pal, who was actually with Space Application Center deputy director earlier. So he told about the new nomenclature about the different clouds, because WMO has names, Cirrus, Cumulonimbus, or all different names. But he gave different Hindi names of this clouds. A very interesting article about that also. It is there. So you people can read about and about the glacier monitoring. But article is there by Dr. Rathore. And then about this, Indian Ocean warming, why the warming is there. And morning I was talking about it, sea surface temperature, how the satellite observations are there, and why warming is there. About that one article is there. Desert in the ocean, very interesting topic. Rimjim has written about that. That is called it biological deserts in the ocean, where the primary productivity is less. So about that topic is there. And then ocean wind interaction. So very good articles about this. Normally we have in this newsletter every time articles related to this meteorology, oceanography. Articles are there. This is about climate change article you can see. And then this is one more article of biooptical themes. In addition to that, we have all this current science news in this newsletter. So all of you can go through newsletters, these newsletters. So by that also you will be knowing about how the things are happening, or what is the going on, maybe in the future, near future, what is going to happen. So that through newsletter we have all these things. It's interesting. In addition to that, I think 2 years back we started Students Corner. So young students, maybe you can see from even senior KG students what they feel about it, meteorology or oceanography or climate science. So sometimes they put their drawings, sometimes they put their poems. So all those things also. So that, but through that also they also get encouragement, and then through that they learn about these things also, because we interact with them. So these are some of the things. Normally, this is one of the poem by class 6th and 7 students. So, to encourage them, normally we put their pictures also. So in the 2021, the whoever students have given the articles, we put their pictures in that, so that more and more people get encouragement about that. So this is about what normally we do, outreach of this Indian Meteorological Society through Ahmedabad chapter. In addition, as I was talking about, whole headquarters to headquarter, we have that outreach program. National Committee also does a lot of activities, lot of lecture, lot of discussion, in addition to the annual symposiums as well as the meetings, seminars. It is happening, but different chapters also regularly do this. Sometimes they will do exhibitions about the meteorological sciences in that. So I hope some of you may be interested through these things, and you people can come up to this our site or IMS, normal IMS site, headquarters site also, and go through our newsletters. These are the open newsletter. Anybody can download it and go through it and join our society, so that you can know more about it also, as well as you can also contribute to the society by whatever knowledge you are having, or if you are interested to contribute in any other way also, you are most welcome to contribute. Thank you.
Thank you very much, Dr. Rajkumar, to give a very detailed view of the activities of Indian Meteorological Society, and I'm sure that students have really liked it, and it is request to all the students to get in touch with Dr. Rajkumar or Indian Meteorological Society, so that they get connected with the society, and which will be beneficial to students. If there are any questions from participants online or students who are watching it, we can even have questions from students in their mother tongue, and faculties can translate it uh, for the speaker. Sir, what about any NGOs? I mean, how can get in touch with Indian Meteorological Society, especially the NGOs which are working in the field of education and science? Because now it is that in the school texts I saw in CBSE board and even in the state board school, they have given a lot of thrust on the topics like climate and weather. So how in that context one can get associated with the Indian Meteorological Society?
Very good question. Actually, they can always come to us or write to us, or maybe very informally. It is not that any formal thing has to be done. Any activity they want to do related to climate science or weather science, they can propose, and we can do together these type of activity. Normally, we do, as I was telling, with different professional societies. We do all these activities, and we do with the Gujarat Science Center also. These normally activities. So any NGOs also we can do such activity, but should be related to the what is bringing about this meteorology. It should not be any related to commercial activity. It should be related to awareness about the meteorology. We will be very happy to do with them also, or we can help them to do that.
Professor Mathur, Mathur sir, are you there?
Yeah.
Sorry,
You're asking me or somebody?
No, I'm actually calling Mathur sir.
He's there, I think. His mic is off.
Sir, another question to you. I mean, what kind of projects can be done with school students related with climate or weather?
Yeah, projects means, as I told, once we started that 1 year we did, still we have actually some instruments. Last year also we are thinking some instruments we are having about this monitoring actually related to the Ahmedabad itself, what we call it the urban heat island type of thing. We put the instruments at different places in Ahmedabad and monitor for a whole year how these things are changing. And maybe in the places where the more concrete is there, jungle is there, or where the places like greenery is there. So such thing we did. If any NGO is interested, because somebody has to take responsibility of the instruments. Some instruments are very cheap. I was talking about which we gave to the students. It was something a few hundred rupees instruments. But some instruments are costly. So if any NGO or any schools come forward, we would like to have such experiment with them, because we are our members, they can do with them, they can train them, and they can together they can do, they can teach to the students, you have to do this way, you have to take observation particular way, they can guide, so the student themselves can take this such projects they can take. Like a whole year, if they take observation, they can write a small report. What were their observation for the whole year for that particular area or location, and why it happened. Such thing can be done.
Sir, for undergraduate and postgraduate students, can they how can they do any technical project with the members of the society, or what kind of other opportunities are there in the field of climate and weather?
Yes, actually they can do, but actually only problem I can say constraint with them will be there, because they need the certificate. The certificate we can give from the society if it is useful for them. Society can give the certificates, but that may not be much useful, because any student, if he does any project, he or she wants from the any particular institute. So that way, what we do for that members, all members are mostly attached to any particular institute, government institute like that, either college, university, or the like ISRO. So those students normally come to the ISRO like that to us. We guide them for the project. That way also they do on the meteorology itself. Like morning I was talking about the some project, collaborative projects or MTech project, they come, that they do, but as not as a society, because society as it they do also, they will not be getting recognition as such from the if I write I am guide or particular, I guided any project for a student, they may not get benefit unless it is has a seal of particular institute. So
so if there are no other questions from participants, I thank Dr. Rajkumar for spending his valuable time with us and with his expertise again for his talk previously and now to share the activities of Indian Meteorological Society. So it was we are really privileged to sir have you, and I'm sure students uh, have noted down all the information about society, and faculty students they will get in touch with the society to follow up their interest.
thank you.
Thank you very much.
Thank you.
Just call Professor Mathur. Maybe we can take 10 minutes break, and we'll join after 10 minutes.
But I'm audible?
Yes, sir.
No.
Yes, sir, you are audible, sir.
Okay, ठीक है. So
I called Dr. Veena, so she said she just joining in 2 minutes. And I also requested to have some comments from students also. So even 3-4 students will be joining.
Yes, Chintamani, are you waiting for someone? How many are expected to join now?
Veena is joining 3 students.
ತಮ್ಮ ತಮ್ಮ ಹೇಳ್ಕೊಂಡವ
Sir, shall we start?
also joining. So, can you hear me, Mathur sir?
Yes, I can listen.
Dr. Veena told me that the principal sir will be joining, so they are just wait for 2 minutes. They told me.
Okay. Let us wait for a few minutes.
Veena, are you there? Dr. Veena, are you there? Hello. Yeah. Yes, yes. I'll start now. Hello, everyone. So as we concluding section of the days long awareness webinar series, the challenges and opportunities for science students in space sciences, it brings me immense pleasure.
Chintamani, your voice is distorting, not clear.
Clear? Am I audible now?
Now audible.
Hello, everyone.
Yeah.
Now we move to the 2 days long awareness webinar series on opportunities and challenges for science students in sciences. It's immense to be part of the 4 days long awareness webinar series, and as we are now part of the session, I invite all the dignitaries, Professor A.C. Mathur, Professor Jain, and of PC Jabin College, Dr. Horakeri.
आई थिंक जनाब चिंतामणि का भी थोड़ा प्रॉब्लम है आवाज का आप टेक ओवर कर लो इफ योर वॉइस इज ओके
I'm back, sir. Am I audible now?
Now it is perfect. You please stand and be closer to the mic.
थोड़ा ब्रेक हो जाता है बीच में.
So as we move to the concluding session of this 2 days long webinar series on challenges and opportunities for science students in space sciences, it brings me immense pleasure to be a part of this workshop and to overall have a discussion. And as a part of this concluding session, I invite all the dignitaries who have been part of this 2 days long webinar series. Of course, the founder of Indian Space Industries Exhibitors, Professor A.C. Mathur, and Professor V.K. Jain. And I also invite the principal of PC Jabin College, Dr. Horakeri, and the head of the physics department, Dr. Jiragal, and Dr. Veena, who has been coordinating the event. Dr. Veena, are you there?
I'm there, sir.
Yes. Over to you, Dr. Veena. So you can now start.
Good evening, sir.
Good
evening to all. So today we are about to do the conclusion session. So I want to call Dr. L.D. Horkeri, our principal, sir, to join the session. Sir, are you there, sir? So next, I would like to call upon our HOD Department of Physics, Dr. P.R. Jirgol, to join the session.
Yes, sir, I'm here.
Yes, sir. Sir, we can start the conclusion session, sir. Interactive session.
Yes, ma'am. And we would also like to have thoughts from Professor A.C. Mathur and Professor.
Yes, sir. I want to hear, sir. It is it is my immense pleasure to have us Dr. Professor Jain sir and as well as A.C. Mathur sir in our interactive session. It is very nice to hear all the sessions. I want to continue our session that is called conclusion session. Sir, is it possible? It is okay, sir, if I call our student to speak about the session?
Yes.
Before that,
all a few students, they should speak about the total series, how they liked it, and any suggestion is there for improvement. Same way, our Jain sir also will speak, and your principal sir also can speak for a few minutes.
Yes, sir.
Our HOD also can speak. Everybody should give their views in short.
Yes, sir. I'll over to my HOD sir, Jirgal sir. Over to Jirgal sir.
Principal sir wants to say.
Has he joined?
Yes, he has joined.
Let him speak first.
Good afternoon to all the dignitaries. And I, Dr. P.R. Jirgal, head of the Department of Physics, Species Habitat Science College, Hubble, that I would like to express my happiness towards this two-day webinar series. And right from the beginning, we observed and I got the feedback from our students. There is a feedback from our students, so that right from the beginning, that is up to the last session, the resource persons were so good, their delivery was so excellent, and all our students, they definitely benefited, and because of all this is the resource persons, our students are motivated and came to know about the opportunities in the space science. Sir, really, I'm very thankful to the Indian space industries exhibitor team. Because of their support and collaboration, we could able to arrange such a kind of webinar series. With this one now, definitely our students have got benefited, sir. Really, I'm very happy on behalf of the principal and our society, KLA society, and our college, Species Habitat Science College, and my own department on behalf of my students and faculty. I'm going to express heartfelt thanks to the team of what now Indian Space industry exhibitors, sir. I'm very thankful to you, sir. in the course of the time, I expect the same kind of association, and we are willing to organize such a kind of activities in the future, sir. Thank you for the entire team, sir.
Thank you very much.
Sir, sir, Dr. Urkeri, sir. Sir, please give the feedback and interact with you, sir.
Okay.
Sir, is it audible, sir?
Yes, yes, very clear. Please go ahead.
Sir. Sir, Urkeri, sir. Can you hear me, sir? Please interact and tell few words about this session, sir.
I think there is some net issue.
Next, I call upon the student participant, Ms. Sarna to speak some few words about the 2-day awareness program. Over to Sarna. Sarna, please.
Yes, sir. Good evening, one and all. My name is Swarna SS, student of PC Jamin College. Thank you for the wonderful opportunities and detailed explanation about various concepts related to space science technology. We had the wonderful interactions with the great personalities from ISRO, Space Application Center, Space Education and Research Foundation, and IIST. Thank you for putting insight into the career opportunities in an expanding area with great potential for upcoming generation. Special thanks to Sri Chintamani sir and Alok Mathur sir from Space Geeks, Mumbai, for making this online webinar more effective. Thank you.
Thank you, Sarna.
Thank you.
Now, another student participant.
So thank you very much for giving me this opportunity. And I would like to talk about the expedition, the Antarctica expedition that's called Dakshin Gangotri by H.K. Gupta. And it was very enlightening. It was a true miracle that we had, that Indian people had able to set up a base in Antarctica. That was a very insightful thing. And I would like to talk about the application challenges and opportunity in space by Hariom Watts. And he gave a very insightful discoveries into the opportunity that our students can have in the space science and technologies. Then I would like to thank Dr. Alok Mathur for giving a very good insight into the weather science and the prediction of cyclones and weather prediction is very important in our day-to-day life. It's also very important for farmers for finding the right opportunity for planting crops and other things. And also I would like to thank Dr. KG Srija Lakshmi from IIST Trivandrum for the insight into space biology application challenges and opportunities, because we don't usually, when physicists don't bother about biology, but it actually matters how the human body changes in the microgravity, or we call in space. And then the very important thing about the satellites is remote sensing, which gives us a lot of opportunities into finding the detailed stuff about the Earth, like the vapor pressure, the wind speed, the cloud density, and all other things, by Dr. Ajit Roy. And and application challenges and opportunities in optics for space research and application, because as we know in remote sensing, the way of the use of lenses and optics is very important to find the area to be covered and to be done. And this is all I would like to conclude about our webinar about the stuff that happened today. Thank you very much.
Thank you.
Thank you, Melvin. Now I request our beloved principal, Dr. L.D. Horkeri sir, to speak a few words about the 2 days awareness program. Over to Horkeri sir.
Good evening to one and all present over here. In fact, it gives me a great pleasure to express my sincere gratitudes to all the resource persons, starting from Sri B.D. Mehta. So Sri B.D. Mehta has fascinatingly expressed the activities of Indian Space Industries Exhibitor, that is ISIE Ahmedabad. So we came to know the activities of this ISIE. So a very fascinating talk he has given. Then Padma Shri Dr. H.K. Gupta, Dr. Hari Om Vats. So all the resource persons, all the galaxy of resource persons, galaxy of senior scientists have given their fascinating talks. So on behalf of our college staff and students, I am very much grateful to all the resource persons, and we are expecting say offline meetings, sir, with all of you. So if it is possible, you can, I am requesting you to come down to Hubble, and that is in Karnataka. So we can have a offline interaction with our students and staff. So it will be more beneficial to our staff and students regarding Indian space activities. So with this, once again, I submit my sincere gratitudes to all the resource persons. Thank you. Thanks a lot.
Professor A.C. Mathur, I invite you to, and Professor V.K. Jain, express thoughts about this webinar.
Chintamani sir, thank you, Horkeri sir. Chintamani sir.
Okay, thank you, Chintamani, for giving me a chance to speak here. In this 2 days webinar series, we had a very good interaction with the PC Jamin Science College students and the faculty. And the students, large number, they showed a lot of interest for science students. And hopefully in future we will have an offline seminar in their college itself, where we can take faculty from SAC and PRL, and we can discuss. When there is a physical interaction, I think students becomes more interactive and they ask a lot of questions. So in these 2 days, we have found that students could not ask much question. I don't know the reason, whether there was some communication problem their end or something else. So when they interact with these senior scientists, they will learn more. And
Yes, sir, definitely
in future we will have more activities with the college related with the science, because this PC Jamin College is very famous. It is a very old college of science there. So we'll have more scientific activities in nature. And the faculty, those who want to take up some research projects with ISRO, they can also show interest, and there are various schemes of ISRO where they support the college financially and scientifically for doing advanced research in the field of space. Yeah, thank you very much.
Thank you, sir. Thank you very much, sir. Thank you, sir.
Now I request Professor V.K. Jain to express his thoughts about the webinar.
I think Chintamani, Dr. P.S. Thakkar is also here. He is a senior scientist from ISRO Ahmedabad. He is, I found he has attended a number of lectures. He was present till I think 1 hour back or so. If he is there, you can take his views also about the total program.
Yeah, thank you very much, Mr. Chintamani Pai, for inviting me for this concluding session. I'm really happy to see
the enthusiasm of taken by this college, PC Jabin Science College. And I hope that all students might have got some idea about the space. There are a lot of scope. They are from not only communication and from the space, also from the ground, they can work on many fields. They can work in rocket field, they can work in basic physics, maths, even biology is there. So the whosoever is doing science, not doing engineering, they also will have the lot of opportunity. They should not feel frustrated. They can at our place in ISRO, there are several scientists, and you have today might have listened several talks about the Earth observations and this thing by Dr. Rajkumar and others also, and so from IST also, Dr. I think one speaker, that is Arjit Rai. So basically these persons are scientists and they have risen to very high level. Dr. Rajkumar was our ex-deputy director from SAC and he has reached to director levels, now he's retired. So you see, lot of subjects they have got. Everybody is having, they can go to basic science, physics, biology, chemistry, they can go to astronomy. So by attending these seminar by the students, they are, I think they can, their mind will explode. Somebody should not feel inside that they are in chemistry background or a chemical, because a lot of things can be done in the rocketry science. A lot of work can be done in orbitics, mathematical thing. So they will have tremendous potential. So I'm thankful that college has organized such a wonderful seminar, and our ISI is grateful for inviting us for such a where we can educate the students and they can enhance their brains, their thinking, that a sky is open. So if somebody is doing biology or geology also, because that a human space flights, Gagan mission is there. There are not only communication field or launching field only, but a lot of science is involved everywhere. So the people can go, have gone up to that Antarctica, Gangotri. Many of our Indians like Rakesh Sharma, Kalpana, etc., they have gone to space. So many things are there. So I think this seminar will enlighten the minds of the students, and then if they want some advanced subject also, because this is kind of awareness only. We could not teach you many things, but definitely we are happy if you interact with our team, engineers, scientists, and also our resource person. And whatever query in your mind, I think we will take up and will certainly helpful to you. Thank you very much inviting me for us to this wonderful seminar and for concluding remark. Thank you. Now over to Chintamani.
Thank you, sir, for your valuable feedback. Now, as Professor Mathur suggested, I would like to request Professor Thakkar to give his feedback and express his thoughts overall about the webinar series. Is Professor Thakkar there?
Prabhu Thakkar is the Thakkar. The name is being displayed probably. He can be somewhere else. Probably. He speak unmute. So you can ask afterwards. You can take next.
Any other students who would like to express their feedback? Maybe any other faculty from college, they would like to express their feedback.
Chintamani sir, it is not audible. Chintamani sir.
Any faculty member would like to, any faculty member would like to give a feedback? Any faculty member would like to give a feedback? Any faculty member? Am I audible? Now? Am I audible now?
Yes.
Any faculty member from PC Jabin College would like to give their feedback about the webinar series? Veena, can you request any faculty member to give their feedback? Professor Santosh, Professor Deshpande was there, so they can, in general, feedback and they can express their thoughts.
Chintamani sir. Yes, shall we go to the last stage?
Yes. Professor Thakkar, is he joining, sir? I can see him online. What do you suggest, Mathu sir?
Yeah, I think if there is no other comment from anyone, you can proceed. If somebody has been authorized for a vote of thanks, you can ask. Otherwise, officially you can close the meeting.
Professor Santosh, you can proceed.
Yes, sir. Yes, sir. Thank you, sir. Actually, the two-day the awareness program was very interesting, and a lot of our students have been benefited space science and research. And I'm very much thankful to Anil Mathur sir and Chintamani sir for supporting us. And not only this, in our college management, our principal, our head of the department, and all the faculty members have been contributed in making this grand success. And now I request our beloved colleague, Sri Viresh Hiramat sir, to propose the vote of thanks. Over to Viresh Hiramat sir.
Good evening, everyone. I, Viresh G. Hiramat, Assistant Professor, Department of Physics, PC Jabin Science College, Hubble. It gives me an immense pleasure to propose a vote of thanks to all dignitaries present over here. On behalf of our Physics Department, PC Jabin Science College, Hubble, I would like to express my gratitude to all extreme dignitaries of this webinar series for their presence and contributions to make this webinar series a great success. I would like to thank Indian Space Industries exhibitors for their collaborative work. I would like to thank all the honorable resource persons, that is Padma Shri Dr. H.K. Gupta sir, Dr. Hariom Vach, Dr. D.R.M. Samudrai, Dr. Alok Mathur sir, Dr. K.G. Srijalakshmi, Dr. Yamar Shivaraman, Mr. Himanshu Shukla, Dr. Ajit Roy, Dr. Rajkumar, Dr. Shashi Kiran Ganesh, Dr. Sumanta Sharkel, and last but not the least, Sir Anil C. Mathur and Chintamani Pai sir, for enlightening us with a great career choice in space science. Now, I would like to extend my gratitude to Kelly Education Society for giving us the wonderful opportunity to conduct this webinar series. A special thanks to Dr. L.D. Horkeri principal of PC Jabin Science College, for providing an immense support to make this webinar successful. I extend my gratitude to our Dr. Jirga sir, HOD, Department of Physics. I must thank convener Dr. Veena E. Madam for planning and executing the webinar series a great successful. A special thanks to the organizing team and all my colleagues who worked hard for the part of few days to make this webinar series a great success. Thank you one and all.
Thank you very much, sir. I think we all can take a group photo. Maybe everyone can switch on their videos. And before we log out, we will take a photo, group photo. So I request everyone. It was great pleasure to have you all. I'm sure students will have a great time after this webinar series. I'm now taking a screenshot. Yeah.
All are requested to switch on the camera, please.
Yeah, I'll take the screenshot now. One more. Okay. I think once again, I thank everyone and all.
Okay. Thank you very much. Thanks to all.
Thank you very much. Bye.
Thank you, sir.
Thank you, sir.
Thank you, Ananda. It was a nice.
Log out now. Thank you.
Dear participants, we are about to send the feedback link in the respective WhatsApp group, and please kindly share your feedback through the feedback form, and we are sending through your email ID.